Amazon EC2 FAQs General Overview Q. What is Amazon Elastic Compute Cloud? Amazon EC2. Amazon Elastic Compute Cloud, Amazon EC2, is a web service that provides resizable compute capacity in the cloud. It is designed to make web-scale computing easier for developers. Q. What can I do with Amazon EC2? Just as Amazon Simple Storage Service, Amazon S3, enables storage in the cloud, Amazon EC2 enables compute in the cloud. Amazon EC2's simple web service interface allows you to obtain and configure capacity with minimal friction. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. Amazon EC2 reduces the time required to obtain and boot new server instances to minutes, allowing you to quickly scale capacity, both up and down, as your computing requirements change. Amazon EC2 changes the economics of computing by allowing you to pay only for capacity that you actually use. Q. How can I get started with Amazon EC2? To sign up for Amazon EC2, click the Sign Up for this web service button on the Amazon EC2 detail page. You must have an Amazon Web Services account to access this service. If you do not already have one, you will be prompted to create one when you begin the Amazon EC2 sign-up process. After signing up, please refer to the Amazon EC2 documentation, which includes our Getting Started guide. Q. Why am I asked to verify my phone number when signing up for Amazon EC2? Amazon EC2 registration requires you to have a valid phone number and email address on file with AWS in case we ever need to contact you. Verifying your phone number takes only a couple of minutes and involves receiving a phone call during the registration process and entering a PIN number using the phone keypad. Q. What can developers now do that they could not before? Until now, small developers did not have the capital to acquire massive compute resources and ensure they had the capacity they needed to handle unexpected spikes in load. Amazon EC2 enables any developer to leverage Amazon's own benefits of massive scale with no upfront investment or performance compromises. Developers are now free to innovate, knowing that no matter how successful their businesses become, it will be inexpensive and simple to ensure they have the compute capacity they need to meet their business requirements. The elastic nature of the service allows developers to instantly scale to meet spikes in traffic or demand. When computing requirements unexpectedly change, up or down, Amazon EC2 can instantly respond, meaning that developers have the ability to control how many resources are in use at any given point in time. In contrast, traditional hosting services generally provide a fixed number of resources for a fixed amount of time, meaning that users have a limited ability to easily respond when their usage is rapidly changing, unpredictable, or is known to experience large peaks at various intervals. Q. How do I run systems in the Amazon EC2 environment? Once you have set up your account and select or create your AMIs, you are ready to boot your instance. You can start your AMI on any number of on-demand instances by using the Run Instances API call. You simply need to indicate how many instances you wish to launch. If you wish to run more than your on-demand quota, complete the Amazon EC2 instance request form. If Amazon EC2 is able to fulfill your request, Run Instances will return success, and we will start launching your instances. You can check on the status of your instances using the Describe Instances API call. You can also programmatically terminate any number of your instances using the Terminate Instances API call. If you have a running instance using an Amazon EBS boot partition, you can also use the Stop Instances API call to release the compute resources but preserve the data on the boot partition. You can use the Start Instances API when you are ready to restart the associated instance with the Amazon EBS boot partition. In addition, you have the option to use Spot Instances to reduce your computing costs when you have flexibility and when your applications can run. Read more about Spot Instances for a more detailed explanation on how Spot Instances work. If you prefer, you can also perform all these actions from the AWS Management Console or through the command line using our command line tools, which have been implemented with this web service API. Q. What is the difference between using the local instance store and Amazon Elastic Block Store, Amazon EBS, for the root device? When you launch your Amazon EC2 instances, you have the ability to store your root device data on Amazon EBS or the local instance store. By using Amazon EBS, data on the root device will persist independently from the lifetime of the instance. This enables you to stop and restart the instance at a subsequent time, which is similar to shutting down your laptop and restarting it when you need it again. Alternatively, the local instance store only persists during the life of the instance. This is an inexpensive way to launch instances where data is not stored to the root device. For example, some customers use this option to run large websites where each instance is a clone to handle web traffic. Q. How quickly will systems be running? It typically takes less than 10 minutes from the issue of the run instances call to the point where all requested instances begin their boot sequences. This time depends on a number of factors including the size of your AMI, the number of instances you're launching, and how recently you have launched that AMI. Images launched for the first time may take slightly longer to boot. Q. How do I load and store my systems with Amazon EC2? Amazon EC2 allows you to set up and configure everything about your instances from your operating system up to your applications. An Amazon Machine Image, AMI, is simply a packaged up environment that includes all the necessary bits to set up and boot your instance. Your AMIs are your unit of deployment. You might have just one AMI or you might compose your system out of several building block AMIs, for example, web servers, app servers, and databases. Amazon EC2 provides a number of tools to make creating an AMI easy. Once you create a custom AMI, you will need to bundle it. If you are bundling an image with a root device backed by Amazon EBS, you can simply use the bundle command in the AWS Management Console. If you are bundling an image with a boot partition on the instance store, then you will need to use the AMI tools to upload it to Amazon S3. Amazon EC2 uses Amazon EBS and Amazon S3 to provide reliable, scalable storage of your AMIs so that we can boot them when you ask us to do so. Or, if you want, you don't have to set up your own AMI from scratch. You can choose from a number of globally available AMIs that provide useful instances. For example, if you just want a simple Linux server, you can choose one of the standard Linux distribution AMIs. Q. How do I access my systems? The run instances call that initiates execution of your application stack will return a set of DNS names, one for each system that is being booted. This name can be used to access the system exactly as you would if it were in your own data center. You own that machine while your operating system stack is executing on it. Q. Is Amazon EC2 used in conjunction with Amazon S3? Yes, Amazon EC2 is used jointly with Amazon S3 for instances with root devices backed by local instance storage. By using Amazon S3, developers have access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. In order to execute systems in the Amazon EC2 environment, developers use the tools provided to load their AMIs into Amazon S3 and to move them between Amazon S3 and Amazon EC2. See how do I load and store my systems with Amazon EC2? For more information about AMIs. We expect developers to find the combination of Amazon EC2 and Amazon S3 to be very useful. Amazon EC2 provides cheap, scalable compute in the cloud while Amazon S3 allows users to store their data reliably. Q. How many instances can I run in Amazon EC2? You are limited to running on-demand instances per your CPU-based on-demand instance limit, purchasing 20 reserved instances, and requesting spot instances per your dynamic spot limit per region. New AWS accounts may start with limits that are lower than the limits described here. If you need more instances, complete the Amazon EC2 limit increase request form with your use case, and your limit increase will be considered. Limit increases are tied to the region they were requested for. Q. Are there any limitations in sending email from Amazon EC2 instances? Yes. In order to maintain the quality of Amazon EC2 addresses for sending email, we enforce default limits on the amount of email that can be sent from EC2 accounts. If you wish to send larger amounts of email from EC2, you can apply to have these limits removed from your account by filling out this form. Q. How quickly can I scale my capacity both up and down? Amazon EC2 provides a truly elastic computing environment. Amazon EC2 enables you to increase or decrease capacity within minutes, not hours or days. You can commission one, hundreds or even thousands of server instances simultaneously. When you need more instances, you simply call run instances, and Amazon EC2 will typically set up your new instances in a matter of minutes. Of course, because this is all controlled with web service APIs, your application can automatically scale itself up and down depending on its needs. Q. What operating system environments are supported? Amazon EC2 currently supports a variety of operating systems including Amazon Linux, Ubuntu, Windows Server, Red Hat Enterprise Linux, SUSE Linux Enterprise Server, OpenSUSE Leap, Fedora, Fedora Core OS, Debian, CentOS, Gentoo Linux, Oracle Linux, and FreeBSD. We are looking for ways to expand it to other platforms. Q. Does Amazon EC2 use ECC memory? In our experience, ECC memory is necessary for server infrastructure, and all the hardware underlying Amazon EC2 uses ECC memory. Q. How is this service different than a plain hosting service? Traditional hosting services generally provide a pre-configured resource for a fixed amount of time and at a predetermined cost. Amazon EC2 differs fundamentally in the flexibility, control, and significant cost savings it offers developers, allowing them to treat Amazon EC2 as their own personal data center with the benefit of Amazon.com's robust infrastructure. When computing requirements unexpectedly change, up or down, Amazon EC2 can instantly respond, meaning that developers have the ability to control how many resources are in use at any given point in time. In contrast, traditional hosting services generally provide a fixed number of resources for a fixed amount of time, meaning that users have a limited ability to easily respond when their usage is rapidly changing, unpredictable, or is known to experience large peaks at various intervals. Secondly, many hosting services don't provide full control over the compute resources being provided. Using Amazon EC2, developers can choose not only to initiate or shut down instances at any time, they can completely customize the configuration of their instances to suit their needs, and change it at any time. Most hosting services cater more towards groups of users with similar system requirements, and so offer limited ability to change these. Finally, with Amazon EC2, developers enjoy the benefit of paying only for their actual resource consumption, and at very low rates. Most hosting services require users to pay a fixed, upfront fee irrespective of their actual computing power used, and so users risk overbuying resources to compensate for the inability to quickly scale up resources within a short time frame. EC2 on-demand instance limits. Q. What is changing? Amazon EC2 is transitioning on-demand instance limits from the current instance count-based limits to the new CPU-based limits to simplify the limit management experience for AWS customers. Usage toward the CPU-based limit is measured in terms of number of VPUs, virtual central processing units, for the Amazon EC2 instance types to launch any combination of instance types that meet your application needs. Q. What are CPU-based limits? You are limited to running one or more on-demand instances in an AWS account, and Amazon EC2 measures usage towards each limit based on the total number of VPUs, virtual central processing unit, that are assigned to the running on-demand instances in your AWS account. The following table shows the number of VPUs for each instance size. The CPU mapping for some instance types may differ. See Amazon EC2 instance types for details. Q. How many on-demand instances can I run in Amazon EC2? There are 5 CPU-based instance limits, each defines the amount of capacity you can use of a given instance family. All usage of instances in a given family, regardless of generation, size, or configuration variant, for example disk, processor type, will accrue towards the family's total CPU limit. Listed in the table below. New AWS accounts may start with limits that are lower than the limits described here. Q. Are these on-demand instance CPU-based limits regional? Yes, the on-demand instance limits for an AWS account are set on a per-region basis. Q. Will these limits change over time? Yes, limits can change over time. Amazon EC2 is constantly monitoring your usage within each region, and your limits are raised automatically based on your use of EC2. Q. How can I request a limit increase? Even though EC2 automatically increases your on-demand instance limits based on your usage, if needed you can request a limit increases from the limits page on Amazon EC2 console, the Amazon EC2 service page on the Service Quotas console, or the Service Quotas API/CLI. Q. How can I calculate my new CPU limit? You can find the CPU mapping for each of the Amazon EC2 instance types or use the simplified CPU calculator to compute the total CPU limit requirements for your AWS account. Q. Do CPU limits apply when purchasing reserved instances or requesting spot instances? No, the CPU-based limits only apply to running on-demand instances and spot instances. Q. How can I view my current on-demand instance limits? You can find your current on-demand instance limits on the EC2 service limits page in the Amazon EC2 console, or from the Service Quotas console and APIs. Q. Will this affect running instances? No, opting into CPU-based limits will not affect any running instances. Q. Can I still launch the same number of instances? Yes, the CPU-based instance limits allow you to launch at least the same number of instances as count-based instance limits. Q. Will I be able to view instance usage against these limits? With the Amazon CloudWatch metrics integration, you can view EC2 usage against limits in the Service Quotas console. Service Quotas also enables customers to use CloudWatch for configuring alarms to warn customers of approaching limits. In addition, you can continue to track and inspect your instance usage in Trusted Advisor and Limit Monitor. Q. Will I still be able to use the Describe Account Attributes API? With its CPU limits, we no longer have total instance limits governing the usage. Hence, the Describe Account Attributes API will no longer return the max instances value. Instead, you can now use the Service Quotas APIs to retrieve information about EC2 limits. You can find more information about the Service Quotas APIs in the AWS documentation. Q. Will the CPU limits have an impact on my monthly bill? No. EC2 usage is still calculated either by the hour or the second, depending on which AMI you're running and the instance type and size you've launched. Q. Will CPU limits be available in all regions? CPU-based instance limits are available in all commercial AWS regions. Changes to EC2 SMTP endpoint policy. Q. What is changing? Starting Jan 27, 2020, Amazon Elastic Compute Cloud, EC2, will begin rolling out a change to restrict email traffic over port 25 by default to protect customers and other recipients from spam and email abuse. Port 25 is typically used as the default SMTP port to send emails. AWS accounts that have requested and had port 25 throttles removed in the past will not be impacted by this change.
Q. I have a valid use case for sending emails to port 25 from EC2.
How can I have these port 25 restrictions removed? If you have a valid use case for sending emails to port 25, SMTP, from EC2, please submit a request to remove email sending limitations to have these restrictions lifted. You can alternately send emails using a different port, or leverage an existing authenticated email relay service such as Amazon Simple Email Service, SES. Service Level Agreement, SLA. Q. What is your Amazon EC2 Service Level Agreement guarantee? Our SLA guarantees a monthly uptime percentage of at least 99.99% for Amazon EC2 and Amazon EBS within a region. Q. How do I know if I qualify for a SLA service credit? You are eligible for SLA credit for either Amazon EC2 or Amazon EBS, whichever was unavailable, or both if both were unavailable, if the region that you are operating in has a monthly uptime percentage of less than 99.99% during any monthly billing cycle. For full details on all of the terms and conditions of the SLA, as well as details on how to submit a claim, please see http://aws.amazon.com/ec2/instance types accelerated computing instances. Q. What are accelerated computing instances? Accelerated computing instance family is a family of instances which use hardware accelerators, or coprocessors, to perform some functions, such as floating point number calculation and graphics processing, more efficiently than is possible in software running on CPUs. Amazon EC2 provides three types of accelerated computing instances: GPU compute instances for general-purpose computing, GPU graphics instances for graphics-intensive applications, and FPGA programmable hardware compute instances for advanced scientific workloads. Q. When should I use GPU graphics and compute instances? GPU instances work best for applications with massive parallelism such as workloads using thousands of threads. Graphics processing is an example with huge computational requirements, where each of the tasks is relatively small, the set of operations performed form a pipeline, and the throughput of this pipeline is more important than the latency of the individual operations. To be able to build applications that exploit this level of parallelism, one needs GPU device-specific knowledge by understanding how to program against various graphics APIs, DirectX, OpenGL, or GPU compute programming models, CUDA, OpenCL. Q. What applications can benefit from P4D? Some of the applications that we expect customers to use P4D for are machine learning workloads like natural language understanding, perception model training for autonomous vehicles, image classification, object detection and recommendation engines. The increased GPU performance can significantly reduce the time to train, and the additional GPU memory will help customers train larger, more complex models. HPC customers can use P4's increased processing performance and GPU memory for seismic analysis, drug discovery, DNA sequencing, and insurance risk modeling. Q. How do P4D instances compare to P3 instances? P4 instances feature NVIDIA's latest generation A100 Tensor Core GPUs to provide on average 2.5x increase in FLOP performance over the previous generation V100 along with 2.5x the GPU memory. P4 instances feature Cascade Lake Intel CPU that has 24C per socket and an additional instruction set for vector neural network instructions. P4 instances will have 1.5x the total system memory and 4x the networking throughput of PED nor 16x compared to P3.16XL. Another key difference is that the NV-switch GPU interconnect throughput will double what was possible on P3, so each GPU can communicate with every other GPU at the same 600 GB per second bidirectional throughput and with single hop latency. This allows application development to consider multiple GPUs and memories as a single large GPU and a unified pool of memory. P4D instances are also deployed in tightly coupled hyperscale clusters, called EC2 Ultra clusters, that enable you to run the most complex multi-node ML training and HPC applications. Q. What are EC2 Ultra clusters and how can I get access? P4D instances are deployed in hyperscale clusters called EC2 Ultra clusters. Each EC2 Ultra cluster is comprised of more than 4,000 NVIDIA A100 Tensor Core GPUs, gigabit scale networking, and scalable low latency storage with FSX for Lustre. Each EC2 Ultra cluster is one of the world's top supercomputers. Anyone can easily spin up P4D instances in EC2 superclusters. For additional help, contact us. Q. Will AMIs I used on P3 and PED work on P4? The P4 AMIs will need new NVIDIA drivers for the A100 GPUs and a newer version of the ENA driver installed. P4 instances are powered by Nitro system and they require AMIs with NVIDIA and ENA driver installed. P4 also comes with new Intel Cascade Lake CPUs, which come with an updated instruction set, thus we recommend using the latest distributions of ML frameworks which take advantage of these new instruction sets for data preprocessing. Q. How are P3 instances different from G3 instances? P3 instances are the next generation of EC2 general-purpose GPU computing instances, powered by up to 8 of the latest generation NVIDIA Tesla V100 GPUs. These new instances significantly improve performance and scalability, and add many new features, including new streaming multiprocessor, SM, architecture for machine learning, ML/deep learning, DL, performance optimization, second generation NVIDIA NVLink high-speed GPU interconnect, and highly tuned HBM2 memory for higher efficiency. G3 instances use NVIDIA Tesla M60 GPUs and provide a high-performance platform for graphics applications using DirectX or OpenGL. NVIDIA Tesla M60 GPUs support NVIDIA Grid Virtual Workstation features, and H.265, HEVC, hardware encoding. Each M60 GPU in G3 instances supports 4 monitors with resolutions up to 4096 by 2160, and is licensed to use NVIDIA Grid Virtual Workstation for one concurrent connected user. Example applications of G3 instances include 3D visualizations, graphics-intensive remote workstation, 3D rendering, application streaming, video encoding, and other server-side graphics workloads. Q. What are the benefits of NVIDIA Volta GV100 GPUs? The new NVIDIA Tesla V100 accelerator incorporates the powerful new Volta GV100 GPU. GV100 not only builds upon the advances of its predecessor, the Pascal GP100 GPU, it significantly improves performance and scalability, and adds many new features that improve programmability. These advances will supercharge HPC, data center, supercomputer, and deep learning systems and applications. Q. Who will benefit from P3 instances? P3 instances with their high computational performance will benefit users in artificial intelligence, AI, machine learning, ML, deep learning, DL, and high-performance computing, HPC, applications. Users includes data scientists, data architects, data analysts, scientific researchers, ML engineers, IT managers and software developers. Key industries include transportation, energy/oil and gas, financial services, banking, insurance, healthcare, pharmaceutical, sciences, IT, retail, manufacturing, high-tech, transportation, government, academia, among many others. Q. What are some key use cases of P3 instances? P3 instance use GPUs to accelerate numerous deep learning systems and applications including autonomous vehicle platforms, speech, image, and text recognition systems, intelligent video analytics, molecular simulations, drug discovery, disease diagnosis, weather forecasting, big data analytics, financial modeling, robotics, factory automation, real-time language translation, online search optimizations, and personalized user recommendations, to name just a few. Q. Why should customers use GPU-powered Amazon P3 instances for AI/ML and HPC? GPU-based compute instances provide greater throughput and performance because they are designed for massively parallel processing using thousands of specialized cores per GPU, versus CPUs offering sequential processing with a few cores. In addition, developers have built hundreds of GPU-optimized scientific HPC applications such as quantum chemistry, molecular dynamics, meteorology, among many others. Research indicates that over 70% of the most popular HPC applications provide built-in support for GPUs. Q. Will P3 instances support EC2 classic networking and Amazon VPC? P3 instances will support VPC only. Q. How are G3 instances different from P2 instances? G3 instances use NVIDIA Tesla M60 GPUs and provide a high-performance platform for graphics applications using DirectX or OpenGL. NVIDIA Tesla M60 GPUs support NVIDIA Grid Virtual Workstation features, and H.265, HEVC, hardware encoding. Each M60 GPU in G3 instances supports 4 monitors with resolutions up to 4096 by 2160, and is licensed to use NVIDIA Grid Virtual Workstation for one concurrent connected user. Example applications of G3 instances include 3D visualizations, graphics-intensive remote workstation, 3D rendering, application streaming, video encoding, and other server-side graphics workloads. P2 instances use NVIDIA Tesla K80 GPUs and are designed for general-purpose GPU computing using the CUDA or OpenCL programming models. P2 instances provide customers with high bandwidth 25 gigabits per second networking, powerful single and double precision floating point capabilities, and error-correcting code, ECC, memory, making them ideal for deep learning, high-performance databases, computational fluid dynamics, computational finance, seismic analysis, molecular modeling, genomics, rendering, and other server-side GPU compute workloads. Q. How are P3 instances different from P2 instances? P3 instances are the next generation of EC2 general-purpose GPU computing instances, powered by up to 8 of the latest generation NVIDIA Volta GV100 GPUs. These new instances significantly improve performance and scalability and add many new features, including new streaming multiprocessor (SM) architecture, optimized for machine learning, ML/deep learning (DL) performance, second-generation NVIDIA NVLink high-speed GPU interconnect, and highly tuned HBM2 memory for higher efficiency. P2 instances use NVIDIA Tesla K80 GPUs and are designed for general-purpose GPU computing using the CUDA or OpenCL programming models. P2 instances provide customers with high bandwidth 25 gigabits per second networking, powerful single and double precision floating point capabilities, and error-correcting code, ECC, memory. Q. What APIs and programming models are supported by GPU graphics and compute instances? P3 instances support CUDA 9 and OpenCL, P2 instances support CUDA 8 and OpenCL 1.2, and G3 instances support DirectX 12, OpenGL 4.5, CUDA 8, and OpenCL 1.2. Q. Where do I get NVIDIA drivers for P3 and G3 instances? There are 2 methods by which NVIDIA drivers may be obtained. There are listings on the AWS Marketplace which offer Amazon Linux AMIs and Windows Server AMIs with the NVIDIA drivers pre-installed. You may also launch 64-bit HVM AMIs and install the drivers yourself. You must visit the NVIDIA driver website and search for the NVIDIA Tesla V100 for P3, NVIDIA Tesla K80 for P2, and NVIDIA Tesla M60 for G3 instances. Q. Which AMIs can I use with P3, P2 and G3 instances? You can currently use Windows Server, SUSE Enterprise Linux, Ubuntu, and Amazon Linux AMIs on P2 and G3 instances. P3 instances only support HVM AMIs. If you want to launch AMIs with operating systems not listed here, contact AWS customer support with your request or reach out through EC2 forums. Q. Does the use of G2 and G3 instances require third-party licenses? Aside from the NVIDIA drivers and Grid SDK, the use of G2 and G3 instances does not necessarily require any third-party licenses. However, you are responsible for determining whether your content or technology used on G2 and G3 instances requires any additional licensing. For example, if you are streaming content, you may need licenses for some or all of that content. If you are using third-party technology such as operating systems, audio and/or video encoders, and decoders from Microsoft, Thomson, Fraunhofer ICE, Sysvel SPA, MPEG-LA, and coding technologies, please consult these providers to determine if a license is required. For example, if you leverage the onboard H.264 video encoder on the NVIDIA Grid GPU, you should reach out to MPEG-LA for guidance, and if you use MP3 technology, you should contact Thomson for guidance. Q. Why am I not getting NVIDIA Grid features on G3 instances using the driver downloaded from NVIDIA website? The NVIDIA Tesla M60 GPU used in G3 instances requires a special NVIDIA Grid driver to enable all advanced graphics features, and 4 monitor support with resolution up to 4096 by 2160. You need to use an AMI with NVIDIA Grid driver pre-installed, or download and install the NVIDIA Grid driver following the AWS documentation. Q. Why am I unable to see the GPU when using Microsoft Remote Desktop? When using Remote Desktop, GPUs using the WDDM driver model are replaced with a non-accelerated Remote Desktop display driver. In order to access your GPU hardware, you need to utilize a different remote access tool, such as VNC. Q. What is Amazon EC2 F1? Amazon EC2 F1 is a compute instance with programmable hardware you can use for application acceleration. The new F1 instance type provides a high-performance, easy-to-access FPGA for developing and deploying custom hardware accelerations. Q. What are FPGAs and why do I need them? FPGAs are programmable integrated circuits that you can configure using software. By using FPGAs you can accelerate your applications up to 30x when compared with servers that use CPUs alone. And, FPGAs are reprogrammable, so you get the flexibility to update and optimize your hardware acceleration without having to redesign the hardware. Q. How does F1 compare with traditional FPGA solutions? F1 is an AWS instance with programmable hardware for application acceleration. With F1, you have access to FPGA hardware in a few simple clicks, reducing the time and cost of full-cycle FPGA development and scale deployment from months or years to days. While FPGA technology has been available for decades, adoption of application acceleration has struggled to be successful in both the development of accelerators and in the business model of selling custom hardware for traditional enterprises, due to time and cost in development infrastructure, hardware design, and at scale deployment. With this offering, customers avoid the undifferentiated heavy lifting associated with developing FPGAs in on-premises data centers. Q. What is an Amazon FPGA image, AFI? The design that you create to program your FPGA is called an Amazon FPGA image, AFI. AWS provides a service to register, manage, copy, query, and delete AFIs. After an AFI is created, it can be loaded on a running F1 instance. You can load multiple AFIs to the same F1 instance, and can switch between AFIs in runtime without reboot. This lets you quickly test and run multiple hardware accelerations in rapid sequence. You can also offer to other customers on the AWS Marketplace a combination of your FPGA acceleration and an AMI with custom software or AFI drivers. Q. How do I list my hardware acceleration on the AWS Marketplace? You would develop your AFI and the software drivers/tools to use this AFI. You would then package these software tools/drivers into an Amazon Machine Image, AMI, in an encrypted format. AWS manages all AFIs in the encrypted format you provide to maintain the security of your code. To sell a product in the AWS Marketplace, you or your company must sign up to be an AWS Marketplace reseller. You would then submit your AMI ID and the AFI IDs intended to be packaged in a single product. AWS Marketplace will take care of cloning the AMI and AFIs to create a product, and associate a product code to these artifacts, such that any end user subscribing to this product code would have access to this AMI and the AFIs. Q. What is available with F1 instances? For developers, AWS is providing a hardware development kit, HDK, to help accelerate development cycles, a FPGA developer AMI for development in the cloud, an SDK for AMIs running the F1 instance, and a set of APIs to register, manage, copy, query, and delete AFIs. Both developers and customers have access to the AWS Marketplace where AFIs can be listed and purchased for use in application accelerations. Q. Do I need to be a FPGA expert to use an F1 instance? AWS customers subscribing to a F1 optimized AMI from AWS Marketplace do not need to know anything about FPGAs to take advantage of the accelerations provided by the F1 instance and the AWS Marketplace. Simply subscribe to an F1 optimized AMI from the AWS Marketplace with an acceleration that matches the workload. The AMI contains all the software necessary for using the FPGA acceleration. Customers need only write software to the specific API for that accelerator and start using the accelerator. Q. I'm a FPGA developer, how do I get started with F1 instances? Developers can get started on the F1 instance by creating an AWS account and downloading the AWS Hardware Development Kit, HDK. The HDK includes documentation on F1, internal FPGA interfaces, and compiler scripts for generating AFI. Developers can start writing their FPGA code to the documented interfaces included in the HDK to create their acceleration function. Developers can launch AWS instances with the FPGA Developer AMI. This AMI includes the development tools needed to compile and simulate the FPGA code. The Developer AMI is best run on the latest C5, M5, or R4 instances. Developers should have experience in the programming languages used for creating FPGA code, i.e. Verilog or VHDL, and an understanding of the operation they wish to accelerate. I'm not an FPGA developer, how do I get started with F1 instances? Customers can get started with F1 instances by selecting an accelerator from the AWS Marketplace, provided by AWS Marketplace sellers, and launching an F1 instance with that AMI. The AMI includes all of the software and APIs for that accelerator. AWS manages programming the FPGA with the AFI for that accelerator. Customers do not need any FPGA experience or knowledge to use these accelerators. They can work completely at the software API level for that accelerator. Does AWS provide a developer kit? Yes. The Hardware Development Kit, HDK, includes simulation tools and simulation models for developers to simulate, debug, build, and register their acceleration code. The HDK includes code samples, compile scripts, debug interfaces, and many other tools you will need to develop the FPGA code for your F1 instances. You can use the HDK either in an AWS-provided AMI, or in your on-premises development environment. These models and scripts are available publicly with an AWS account. Can I use the HDK in my on-premises development environment? Yes. You can use the Hardware Development Kit HDK either in an AWS-provided AMI, or in your on-premises development environment. Can I add an FPGA to any EC2 instance type? No. F1 instances comes in two instance sizes, F1.2's large, F1.4's large, and F1.16 extra large. How do I use the Inferentia chip in Inf1 instances? You can start your workflow by building and training your model in one of the popular ML frameworks such as TensorFlow, PyTorch, or MXNet using GPU instances such as P4, P3, or PEDN. Once the model is trained to your required accuracy, you can use the ML Frameworks API to invoke Neuron, a software development kit for Inferentia, to compile the model for execution on Inferentia chips, load it into Inferentia's memory, and then execute inference calls. In order to get started quickly, you can use AWS Deep Learning AMIs that come pre-installed with ML Frameworks and the Neuron SDK. For a fully managed experience, you will be able to use Amazon SageMaker, which will enable you to seamlessly deploy your trained models on Inf1 instances. When would I use Inf1 versus C5 versus G4 instances for inference? Customers running machine learning models that are sensitive to inference latency and throughput can use Inf1 instances for high-performance, cost-effective inference. For those ML models that are less sensitive to inference latency and throughput, customers can use EC2 C5 instances and utilize the AVX512/VNNI instruction set. For ML models that require access to NVIDIA's CUDA, cuDNN or TensorRT libraries, we recommend using G4 instances. Model characteristics and libraries used models that benefit from low latency and high throughput at low cost, models not sensitive to latency and throughput, models requiring NVIDIA's developer libraries. When should I choose Elastic Inference, A, for inference versus Amazon EC2 Inf1 instances? There are two cases where developers would choose A over Inf1 instances. 1. If you need different CPU and memory sizes than what Inf1 offers, then you can use A to attach acceleration to the EC2 instance with the right mix of CPU and memory for your application. 2. If your performance requirements are significantly lower than what the smallest Inf1 instance provides, then using A could be a more cost-effective choice. For example, if you only need 5 TOPS, enough for processing up to 6 concurrent video streams, then using the smallest slice of A with a C5. Large instance could be up to 50% cheaper than using the smallest size of an Inf1 instance. What ML models, types, and operators are supported by EC2 Inf1 instances using the Inferentia chip? Inferentia chips support the commonly used machine learning models such as single-shot detector, SSD, and ResNet for image recognition/classification, and Transformer and BERT for natural language processing and translation, and many others. A list of supported operators can be found on GitHub. How do I take advantage of AWS Inferentia's Neuron Core pipeline capability to lower latency? Inf1 instances with multiple Inferentia chips, such as Inf 1.6 large or Inf 1.24 large, support a fast chip-to-chip interconnect. Using the neuron processing pipeline capability, you can split your model and load it to local cache memory across multiple chips. The neuron compiler uses ahead-of-time AOT compilation technique to analyze the input model and compile it to fit across the on-chip memory of single or multiple inferentia chips. Doing so enables the neuron cores to have high-speed access to models and not require access to off-chip memory, keeping latency bounded while increasing the overall inference throughput. Q. What is the difference between AWS Neuron and Amazon SageMaker Neo? AWS Neuron is a specialized SDK for AWS inferentia chips that optimizes the machine learning inference performance of inferentia chips. It consists of a compiler, runtime, and profiling tools for AWS inferentia and is required to run inference workloads on EC2 Inf1 instances. On the other hand, Amazon SageMaker Neo is a hardware-agnostic service that consists of a compiler and runtime that enables developers to train machine learning models once, and run them on many different hardware platforms. Compute-optimized instances. Q. When should I use compute-optimized instances? Compute-optimized instances are designed for applications that benefit from high compute power. These applications include compute-intensive applications like high-performance web servers. High-performance computing, HPC, scientific modeling, distributed analytics and machine learning inference. Q. What are Amazon EC2 C6G instances? Amazon EC2 C6G instances are the next generation of compute-optimized instances powered by ARM-based AWS Graviton2 processors. C6G instances deliver up to 40% better price performance over C5 instances. They are built on the AWS Nitro system, a combination of dedicated hardware and Nitro hypervisor. Q. What are some of the ideal use cases for C6G instances? C6G instances deliver significant price performance benefits for compute-intensive workloads such as high-performance computing, HPC, batch processing, ad serving, video encoding, gaming, scientific modeling, distributed analytics, and CPU-based machine learning inference. Customers deploying applications built on open-source software across the C instance family will find the C6G instances an appealing option to realize the best price performance within the instance family. ARM developers can also build their applications directly on native ARM hardware as opposed to cross-compilation or emulation. Q. What are the various storage options available on C6G instances? C6G instances are EBS optimized by default and offer up to 19,000 megabits per second of dedicated EBS bandwidth to both encrypted and unencrypted EBS volumes. C6G instances only support non-volatile memory express interface to access EBS storage volumes. Additionally, options with local instance storage are also available through the C6GD instance types. Q. Which network interface is supported on C6G instances? C6G instances support ENA-based enhanced networking. With ENA, C6G instances can deliver up to 25 gigabits per second of network bandwidth between instances when launched within a placement group. Q. Will customers need to modify their applications and workloads to be able to run on the C6G instances? The changes required are dependent on the application. Customers running applications built on open-source software will find that the ARM ecosystem is well developed and already likely supports their applications. Most Linux distributions as well as containers, Docker, Kubernetes, Amazon ECS, Amazon EKS, Amazon ECR, support the ARM architecture. Customers will find ARM versions of commonly used software packages available for installation through the same mechanisms that they currently use. Applications that are based on interpreted languages such as Java, Node, Python, not reliant on native CPU instruction sets should run with minimal to no changes. Applications developed using compiled languages, C, C++, Golang, will need to be recompiled to generate ARM binaries. The ARM architecture is well supported in these popular programming languages and modern code usually requires a simple make command. Refer to the Getting Started guide on GitHub for more details. Q. Will there be more compute choices offered with the C6 instance families? Yes, we plan to offer Intel and AMD CPU-powered instances in the future as part of the C6 instance families. Q. Can I launch C4 instances as Amazon EBS optimized instances? Each C4 instance type is EBS optimized by default. C4 instances 500 megabits per second to 4000 megabits per second to EBS above and beyond the general purpose network throughput provided to the instance. Since this feature is always enabled on C4 instances, launching a C4 instance explicitly as EBS optimized will not affect the instance's behavior. Q. How can I use the processor state control feature available on the C4.8's large instance? The C4.8's large instance type provides the ability for an operating system to control processor C states and P states. This feature is currently available only on Linux instances. You may want to change C state or P state settings to increase processor performance consistency, reduce latency, or tune your instance for a specific workload. By default, Amazon Linux provides the highest performance configuration that is optimal for most customer workloads. However, if your application would benefit from lower latency at the cost of higher single or dual core frequencies, or from lower frequency sustained performance as opposed to bursty turbo boost frequencies, then you should consider experimenting with the C state or P state configuration options that are available to these instances. For additional information on this feature, see the Amazon EC2 user guide section on processor state control. Q. Which instances are available within Compute Optimized Instances category? C6G instances. Amazon EC2 C6G instances are powered by ARM-based AWS Graviton2 processors. They deliver up to 40% better price performance over current generation C5 instances and are ideal for running advanced compute-intensive workloads. This includes workloads such as high-performance computing, HPC, batch processing, ad serving, video encoding, gaming, scientific modeling, distributed analytics, and CPU-based machine learning inference. C5 instances. C5 instances are the latest generation of EC2 compute-optimized instances. C5 instances are based on Intel Xeon Platinum processors, part of the Intel Xeon Scalable, codenamed Skylake SP or Cascade Lake, processor family, are available in 9 sizes, and offer up to 96 bus and 192 GB memory. C5 instances deliver 25% improvement in price/performance compared to C4 instances. The C5D instances have local storage for workloads that require very low latency and storage access with high random read and write IOPS ability. C5A instances. C5 instances deliver leading x86 price performance for a broad set of compute-intensive workloads including batch processing, distributed analytics, data transformations, log analysis, and web applications. C5A instances feature 2nd Gen 3.3 GHz AMD EEC processors with up to 96 bus and up to 192 GB of memory. The C5AD instances have local storage for workloads that require very low latency and storage access with high random read and write IOPS ability. C5N instances. C5N instances are ideal for applications requiring high network bandwidth and packet rate. The C5N instances are ideal for applications like HPC, data lakes, network appliances as well as applications that require internode communication and the message passing interface, MPI. C5N offer a choice of Intel Xeon Platinum 3.0 GHz processors with up to 72 bus and 192 GB of memory. C4 instances. C4 instances are based on Intel Xeon E5-2666v3, codenamed Haswell, processors. C4 instances are available in 5 sizes and offer up to 36 bus and 60 GB memory. Q. Should I move my workloads from C3 or C4 instances to C5 instances? The generational improvement in CPU performance and lower price of C5 instances, which combined result in a 25% price/performance improvement relative to C4 instances, benefit a broad spectrum of workloads that currently run on C3 or C4 instances. For floating point intensive applications, Intel AVX 512 enables significant improvements in delivered flops by effectively extracting data level parallelism. Customers looking for absolute performance for graphics rendering and HPC workloads that can be accelerated with GPUs or FPGAs should also evaluate other instance families in the Amazon EC2 portfolio that include those resources to find the ideal instance for their workload. Q. Which operating systems/AMIs are supported on C5 instances? EBS-backed HVM AMIs with support for INA networking and booting from based storage can be used with C5 instances. The following AMIs are supported on C5. For optimal local-based SSD storage performance on C5D, Linux kernel version 4.9 Plus is recommended. Q. What are the storage options available to C5 customers? C5 instances use EBS volumes for storage, are EBS optimized by default, and offer up to 9 gigabits per second throughput to both encrypted and unencrypted EBS volumes. C5 instances access EBS volumes via PCI-attached NVM Express interfaces. NVM is an efficient and scalable storage interface commonly used for flash-based SSDs such as local storage provided with i3 and EN instances. Though the interface may provide lower latency compared to Xen paravirtualized block devices, when used to access EBS volumes, the volume type, size, and provisioned IOPS, if applicable, will determine the overall latency and throughput characteristics of the volume. When M is used to provide EBS volumes, they are attached and detached by PCI hot plug. Q. What network interface is supported on C5 instances? C5 instances use the Elastic Network Adapter, ENA, for networking and enable enhanced networking by default. With ENA, C5 instances can utilize up to 25 gigabits per second of network bandwidth. Q. Which storage interface is supported on C5 instances? C5 instances will support only the EBS device model. EBS volumes attached to C5 instances will appear as NIM devices. NIM is a modern storage interface that provides latency reduction and results in increased disk I/O and throughput. Q. How many EBS volumes can be attached to C5 instances? C5 instances support a maximum for 27 EBS volumes for all operating systems. The limit is shared with any attachments which can be found here: http://docs.aws.amazon.com/osec2/latest/user-guide/using-any.html. For example, since every instance has at least one any, if you have 3 additional any attachments on the C4.2's large, you can attach 24 EBS volumes to that instance. Q. What is the underlying hypervisor on C5 instances? C5 instances use a new EC2 hypervisor that is based on core KVM technology. Q. Why does the total memory reported by the operating system not match the advertised memory of the C5 instance type? In C5, portions of the total memory for an instance are reserved from use by the operating system, including areas used by the virtual BIOS for things like ACP tables and for devices like the virtual video RAM. General purpose instances. Q. What are Amazon EC2 Mac instances? Amazon EC2 Mac instances are a family that features the Mac OS operating system, powered by Apple Mac Mini hardware, and built on the AWS Nitro system. Q. How do I get started with Amazon EC2 Mac instances? Once logged into the Amazon EC2 console, navigate to Launch Instance and search for Mac OS. Q. Why are Mac instances not available via reserved instances? EC2 Mac instances are available for purchases on demand or as part of 1 or 3 year savings plans, based on customer demand. We believe these options give customers the optimal pricing options, but we will monitor customer demand for reserved instances. Q. What are Amazon EC2 T4G instances? Amazon EC2 T4G instances are the next generation of general-purpose burstable instances powered by ARM-based AWS Graviton2 processors. T4G instances deliver up to 40% better price performance over T3 instances. They are built on the AWS Nitro system, a combination of dedicated hardware and Nitro hypervisor. Q. What are some of the ideal use cases for T4G instances? T4G instances deliver up to 40% better price performance over T3 instances for a wide variety of burstable general-purpose workloads such as microservices, low-latency interactive applications, small and medium databases, virtual desktops, development environments, code repositories, and business-critical applications. Customers deploying applications built on open-source software across the T-instance family will find the T4G instances an appealing option to realize the best price performance within the instance family. ARM developers can also build their applications directly on native ARM hardware as opposed to cross-compilation or emulation. Q. Who is eligible for T4G free trial? All existing and new customers with an AWS account can take advantage of the T4G free trial. T4G free trial is available for limited time, until June 30, 2021. The start and end time of free trial are as per Coordinated Universal Time, UTC. T4G free trial will be available in addition to the existing AWS free tier on t2.micro/t3.micro. Customers who have exhausted their t2.micro or t3.micro, depending on the region, free tier usage can still benefit from T4G free trial. Q. How can customers get access to the T4G free trial? Until June 30, 2021, all AWS customers will be automatically enrolled in the T4G free trial. During the free trial period, customers who run a T4G.micro instance will automatically get 750 free hours per month deducted from their bill during each month. The 750 hours are calculated in aggregate across all regions in which the T4G.micro instances are used. Q. What is the regional availability of T4G free trial? The T4G free trial is currently available across the AWS US East and Virginia, Ohio, US West, and California, Oregon, Canada, Central, South America, Sao Paulo, Asia Pacific, Mumbai, Singapore, Seoul, Sydney, Tokyo, and Europe, Frankfurt, Ireland, London regions. It is not available in Europe, Stockholm, Asia Pacific, Hong Kong, China, Beijing, and China, Ningxia regions. As part of the free trial, customers can run T4G.micro instances across one or multiple regions of choice from a single cumulative bucket of 750 free hours per month till June 30, 2021. For example, a customer can run T4G.micro in Oregon for 300 hours for a month and run another T4G.micro in Tokyo for 450 hours that same month. This would add up to 750 hours/month of free trial limit. Q. Is there an additional charge for running specific AMIs under the T4G free trial? Under T4G.micro free trial, there will be no AMI charge for Amazon Linux 2 Roll and SUSE Linux AMIs that are available through EC2 Console Quick Start for the first 750 free hours/month. After 750 free hours/month, regular odd prices including AMI charge, if any, will be applicable. The applicable software fees for AWS Marketplace offers with AMI fulfillment options is not included in the free trial. Only the T4G.micro infrastructure cost is included and covered under the free trial. Q. How will the T4G.micro free trial be reflected on my AWS bill? T4G free trial has a monthly billing cycle that starts in the first of every month and ends on the last day of that month. Under the T4G free trial billing plan, customers using T4G.micro will see a $0 line item on their bill under on-demand pricing plan for the first 750 aggregate hours of usage for every month during the free trial period. Customers can start any time during the free trial period and get 750 free hours for the remainder of that month. Any unused hours from the previous month will not be carried over. Customers can launch multiple T4G.micro instances under the free trial. Customers will be notified automatically via email using AWS budgets when their aggregate monthly usage reaches 85% of 750 free hours. When the aggregate instance usage exceeds 750 hours for the monthly billing cycle, customers will be charged based on regular on-demand pricing for the exceeded hours that month. For customers with a Compute Savings Plan or T4G Instance Savings Plan, SV discount will be applied to on-demand pricing for hours beyond the 750 free trial hours. One consideration is if customers have purchased T4G Reserved Instance, RE-Plan applies first to any usage on an hourly basis. For any remaining usage after RE-Plan has been applied, the free trial billing plan takes effect. Q. If customers sign up for consolidated billing, i.e. a single payer account, can they get the T4G free trial for each account that is tied to the payer account? No, customers who use consolidated billing to consolidate payment across multiple accounts will have access to one free trial per organization. Each payer account gets a total aggregate of 750 free hours a month. More details on consolidated billing can be found here. Q. Will customers get charged for surplus CPU credits as a part of T4G free trial? Customers will not have to pay for surplus CPU credits when they exceed the instance's allocated credits during the 750 free hours of T4G free trial program. At the end of free trial or for any usage beyond the 750 free hours per month, all regular billing charges including surplus credits charges will apply. For details on how CPU credits work, please refer to documentation. Q. At the end of free trial, how will a customer be billed for T4G.micro instance? Starting July 1, 2021, customers running on T4G.micro will be automatically switched from the free trial plan to on-demand pricing plan, or RE/SV plan if purchased, and accumulated credits will be set to 0. Customers will receive email notifications 7 days prior to end of free trial period. Automatically that the free trial period will be ending in 7 days. Starting April 1, 2021, if RE-Plan is purchased, the RE-Plans will apply. Otherwise, customers will be charged regular on-demand pricing for T4G.micro. For customer that have the T4G Instance Savings Plan or a Compute Savings Plan, T4G.micro instance billing will apply savings plan discount on their odd pricing. Q. What are Amazon EC2 M6G instances? Amazon EC2 M6G instances are the next generation of general-purpose instances powered by ARM-based AWS Graviton2 processors. M6G instances deliver up to 40% better price/performance over M5 instances. They are built on the AWS Nitro system, a combination of dedicated hardware and Nitro hypervisor. Q. What are the specifications of the new AWS Graviton 2 processors? The AWS Graviton 2 processors deliver up to 7x performance, 4x the number of compute cores, 2x larger caches, 5x faster memory, and 50% faster per core encryption performance than first-generation AWS Graviton processors. Each core of the AWS Graviton 2 processor is a single-threaded CPU. These processors also offer always-on fully encrypted DRAM memory, hardware acceleration for compression workloads, dedicated engines per CPU that double the floating point performance for workloads such as video encoding, and instructions for N8/FP16 CPU-based machine learning inference acceleration. The CPUs are built utilizing 64-bit ARM Neoverse cores and custom silicon designed by AWS on the advanced 7nm manufacturing technology. Q. Is memory encryption supported by AWS Graviton 2 processors? AWS Graviton 2 processors support always-on 256-bit memory encryption to further enhance security. Encryption keys are securely generated within the host system, do not leave the host system, and are irrecoverably destroyed when the host is rebooted or powered down. Memory encryption does not support integration with AWS KMS and customers cannot bring their own keys. Q. What are some of the ideal use cases for M6G instances? M6G instances deliver significant performance and price performance benefits for a broad spectrum of general-purpose workloads such as application servers, gaming servers, microservices, mid-sized databases, and caching fleets. Customers deploying applications built on open-source software across the M instance family will find the M6G instances an appealing option to realize the best price performance within the instance family. ARM developers can also build their applications directly on native ARM hardware as opposed to cross-compilation or emulation. Q. What are the various storage options available on M6G instances? M6G instances are EBS optimized by default and offer up to 19,000 megabits per second of dedicated EBS bandwidth to both encrypted and unencrypted EBS volumes. M6G instances only support non-volatile memory express (NVMe) interface to access EBS storage volumes. Additionally, options with local NV instance storage are also available through the M6GD instance types. Q. Which network interface is supported on M6G instances? M6G instances support ENA-based enhanced networking. With ENA, M6G instances can deliver up to 25 gigabits per second of network bandwidth between instances when launched within a placement group. Q. Will customers need to modify their applications and workloads to be able to run on the M6G instances? The changes required are dependent on the application. Customers running applications built on open source software will find that the ARM ecosystem is well developed and already likely supports their applications. Most Linux distributions as well as containers, Docker, Kubernetes, Amazon ECS, Amazon EKS, Amazon ECR, support the ARM architecture. Customers will find ARM versions of commonly used software packages available for installation through the same mechanisms that they currently use. Applications that are based on interpreted languages, such as Java, Node, Python, not reliant on native CPU instruction sets should run with minimal to no changes. Applications developed using compiled languages, C, C++, Golang, will need to be recompiled to generate ARM binaries. The ARM architecture is well supported in these popular programming languages and modern code usually requires a simple make command. Refer to the Getting Started guide on GitHub for more details. Q. Will there be more compute choices offered with the M6 instance families? Yes, we plan to offer Intel and AMD CPU-powered instances in the future as part of the M6 instance families. Q. What are Amazon EC2 A1 instances? Amazon EC2 A1 instances are general-purpose instances powered by the first-generation AWS Graviton processors that are custom designed by AWS. Q. What are the specifications of the first-generation AWS Graviton processors? AWS Graviton processors are custom designed by AWS utilizing Amazon's extensive expertise in building platform solutions for cloud applications running at scale. These processors are based on the 64-bit ARM instruction set and feature ARM Neoverse cores as well as custom silicon designed by AWS. The cores operate at a frequency of 2.3 GHz. Q. When should I use A1 instances? A1 instances deliver significant cost savings for scale-out workloads that can fit within the available memory footprint. A1 instances are ideal for scale-out applications such as web servers, containerized microservices, and data/log processing. These instances will also appeal to developers, enthusiasts, and educators across the ARM developer community. Q. Will customers have to modify applications and workloads to be able to run on the A1 instances? The changes required are dependent on the application. Applications based on interpreted or runtime compiled languages, for example, Python, Java, PHP, Node.js, should run without modifications. Other applications may need to be recompiled, and those that don't rely on x86 instructions will generally build with minimal to no changes. Q. Which operating systems/AMIs are supported on A1 instances? The following AMIs are supported on A1 instances: Amazon Linux 2, Ubuntu 16.04.4 or newer, Red Hat Enterprise Linux, RHEL 7.6 or newer, SUSE Linux Enterprise Server 15 or newer. Additional AMI support for Fedora, Debian, Ginx Plus are also available through Community AMIs and the AWS Marketplace. EBS-backed HVM AMIs launched on A1 instances require NVENA drivers installed at instance launch. Q. Are there specific AMI requirements to run on M6G and A1 instances? You will need to use the ARM64 AMIs with the M6G and A1 instances. x86 AMIs are not compatible with M6G and A1 instances. Q. When should customers use A1 instances versus the new M6G instances? A1 instances continue to offer significant cost benefits for scale-out workloads that can run on multiple smaller cores and fit within the available memory footprint. The new M6G instances are a good fit for a broad spectrum of applications that require more compute, memory, networking resources and/or can benefit from scaling up across platform capabilities. M6G instances will deliver the best price performance within the instance family for these applications. M6G supports up to 16's large instance size, A1 supports up to 4's large, 4 GB of memory per CPU, A1 supports 2 GB memory per CPU, and up to 25 gigabits per second of networking bandwidth, A1 supports up to 10 gigabits per second. Q. What are the various storage options available to A1 customers? A1 instances are EBS optimized by default and offer up to 3,500 megabits per second of dedicated EBS bandwidth to both encrypted and unencrypted EBS volumes. A1 instances only support non-volatile memory express interface to access EBS storage volumes. A1 instances will not support the bulk front interface. Q. Which network interface is supported on A1 instances? A1 instances support ENA-based enhanced networking. With ENA, A1 instances can deliver up to 10 gigabits per second of network bandwidth between instances when launched within a placement group. Q. Do A1 instances support the AWS Nitro system? Yes, A1 instances are powered by the AWS Nitro system, a combination of dedicated hardware and Nitro hypervisor. Q. Why does the total memory reported by Linux not match the advertised memory of the A1 instance type? In A1 instances, portions of the total memory for an instance are reserved from use by the operating system, including areas used by the virtual UEFI for things like ACPI tables. Q. What are the key use cases for Amazon EC2 M5 instances? M5 instances offer a good choice for running development and test environments, web, mobile and gaming applications, analytics applications, and business-critical applications including ERP, HR, CRM, and collaboration apps. Customers who are interested in running their data-intensive workloads, for example, HPC or Solr clusters, on instances with a higher memory footprint will also find M5 to be a good fit. Workloads that heavily use single and double precision floating point operations and vector processing such as video processing workloads and need higher memory can benefit substantially from the AVX 512 instructions that M5 supports. Q. Why should customers choose EC2 M5 instances over EC2 M4 instances? Compared with EC2 M4 instances, the new EC2 M5 instances deliver customers greater compute and storage performance, larger instance sizes for less cost, consistency and security. The biggest benefit of EC2 M5 instances is based on its usage of the latest generation of Intel Xeon scalable processors, Skylake SP or Cascade Lake, which deliver up to 20% improvement in price/performance compared to M4. With AVX 512 support in M5 versus the older AVX2 in M4, customers will gain 2x higher performance in workloads requiring floating point operations. M5 instances offer up to 25 gigabits per second of network bandwidth and up to 10 gigabits per second of dedicated bandwidth too. Amazon EBS. M5 instances also feature significantly higher networking and Amazon EBS performance on smaller instance sizes with EBS burst capability. Q. How does support for Intel AVX 512 benefit EC2 M5 and M5D instance customers? Intel Advanced Vector Extension 512, AVX 512, is a set of new CPU instructions available on the latest Intel Xeon Scalable processor family that can accelerate performance for workloads and usages such as scientific simulations, financial analytics, artificial intelligence, machine learning/deep learning, 3D modeling and analysis, image and video processing, cryptography and data compression, among others. Intel AVX 512 offers exceptional processing of encryption algorithms, helping to reduce the performance overhead for cryptography, which means EC2 M5 and M5D customers can deploy more secure data and services into distributed environments without compromising performance. Q. What are the various processor options available to M5 customers? The M5 and M5D instance types use a 3.1 GHz Intel Xeon Platinum 8000 series processor. The M5A and M5AT instance types use a 2.5 GHz AMD EAP 7000 series processor. Q. What are the various storage options available to M5 customers? The M5 and M5 instance types leverage EBS volumes for storage. The M5D and M5AT instance types support up to 3.6 TB, 4 by 900 GB, of local NAND storage. Q. When should I use the different M5 instance types? Customers should consider using the M5A and M5AT instance types if they are looking to save money on price when their workloads do not fully utilize the compute resources of their chosen instance, resulting in them paying for performance that they don't actually need. For workloads that require the highest processor performance or high floating point performance capabilities, including vectorized computing with AVX 512 instructions, then we suggest you use the M5 or M5D instance types. Q. Which network interface is supported on M5 instances? M5, M5A, M5D, and M5AT instances support only ENA-based enhanced networking and will not support NetBack. With ENA, M5 and M5D instances can deliver up to 25 gigabits per second of network bandwidth between instances, and the M5A and M5AT instance types can support up to 20 gigabits per second of network bandwidth between instances. Q. Which operating systems/AMIs are supported on M5 instances? EBS-backed HVM AMIs with support for ENA networking and booting from based storage can be used with M5 instances. The following AMIs are supported on M5, M5A, M5AT, and M5D for optimal local NAND-based SSD storage performance on M5D. Linux kernel version 4.9+ is recommended. Q. What interface connects EBS storage to my M5 instances? M5, M5A, M5AT, and M5D instances use EBS volumes for storage, are EBS optimized by default, and offer up to 10 gigabits per second throughput to both encrypted and unencrypted EBS volumes. M5 instances access EBS volumes via PCI-attached NVM Express interfaces. NVM is an efficient and scalable storage interface commonly used for flash-based SSDs such as local NVM storage provided with i3 and ENA instances. Though the NVM interface may provide lower latency compared to Xen para-virtualized block devices, when used to access EBS volumes, the volume type, size, and provisioned IOPS, if applicable, will determine the overall latency and throughput characteristics of the volume. When NVM is used to provide EBS volumes, they are attached and detached by PCI hot plug. Q. How many EBS volumes can be attached to M5 instances? M5 and M5 instances support a maximum for 27 EBS volumes for all operating systems. The limit is shared with any attachments which can be found here: http://docs.aws.amazon.com/osec2/latest/user-guide/using-any.html. For example, since every instance has at least one any, if you have 3 additional any attachments on the M5.2's large, you can attach 24 EBS volumes to that instance. Q. What is the underlying hypervisor on M5 instances? M5, M5A, M5AT, and M5D instances use a new lightweight Nitro hypervisor that is based on Core KVM technology. Q. Why does the total memory reported by the operating system not match the advertised memory of the M5 instance type? In M5, M5A, M5AT, and M5D, portions of the total memory for an instance are reserved from use by the operating system, including areas used by the virtual BIOS for things like ACP tables and for devices like the virtual video RAM. Q. What are M5ZN instances? M5ZN instances are a variant of the M5 general-purpose instances that are powered by the fastest Intel Xeon Scalable processor in the cloud, with an all-core turbo frequency of up to 4.5 GHz, along with 100 gigabits per second networking and support for Amazon FA. M5ZN instances are an ideal fit for workloads such as gaming, financial applications, simulation modeling applications such as those used in the automotive, aerospace, energy, and telecommunication industries, and other high-performance computing applications. Q. How are M5ZN instances different than Z1D instances? Z1D instances are a memory-optimized instance, and feature a high-frequency version of the Intel Xeon scalable processors, up to 4.0 GHz, along with local NAND storage. M5ZN instances are a general-purpose instance, and feature a high-frequency version of the second-generation Intel Xeon scalable processors up to 4.5 GHz, along with up to 100 gigabits per second networking performance, and support for FA. M5ZN instances offer improved price performance compared to Z1D. Q. How are burstable performance instances different? Amazon EC2 allows you to choose between fixed performance instances, for example,
C, M and R instance families, and burstable performance instances, for example,
T2. Burstable performance instances provide a baseline level of CPU performance with the ability to burst above the baseline. T2 instances' baseline performance and ability to burst are governed by CPU credits. Each T2 instance receives CPU credits continuously, the rate of which depends on the instance size. T2 instances accrue CPU credits when they are idle, and consume CPU credits when they are active. A CPU credit provides the performance of a full CPU core for 1 minute. Q. How do I choose the right Amazon Machine Image, AMI, for my T2 instances? You will want to verify that the minimum memory requirements of your operating system and applications are within the memory allocated for each T2 instance size, for example, 512 MB for T2.nano. Operating systems with graphical user interfaces, GUI, that consume significant memory and CPU, for example Microsoft Windows, might need a T2.micro or larger instance size for many use cases. You can find AMI suitable for the T2.nano instance types on AWS Marketplace. Windows customers who do not need the GUI can use the Microsoft Windows Server 2012 R2 Core AMI. Q. When should I choose a burstable performance instance, such as T2? T2 instances provide a cost-effective platform for a broad range of general-purpose production workloads. T2 unlimited instances can sustain high CPU performance for as long as required. If your workloads consistently require CPU usage much higher than the baseline, consider a dedicated CPU instance family such as the M or C. Q. How can I see the CPU credit balance for each T2 instance? You can see the CPU credit balance for each T2 instance in EC2 per instance metrics in Amazon CloudWatch. T2 instances have 4 metrics: CPU credit usage, CPU credit balance, CPU surplus credit balance, and CPU surplus credits charged. CPU credit usage indicates the amount of CPU credits used. CPU credit balance indicates the balance of CPU credits. CPU surplus credit balance indicates credits used for bursting in the absence of earned credits. CPU surplus credits charged indicates credits that are charged when average usage exceeds the baseline. Q. What happens to CPU performance if my T2 instance is running low on credits, CPU credit balance is near zero? If your T2 instance has a zero CPU credit balance, performance will remain at baseline CPU performance. For example, the T2.micro provides baseline CPU performance of 10% of a physical CPU core. If your instance's CPU credit balance is approaching zero, CPU performance will be lowered to baseline performance over a 15-minute interval. Q. Does my T2 instance credit balance persist at stop/start? No, a stopped instance does not retain its previously earned credit balance. Q. Can T2 instances be purchased as reserved instances or spot instances? T2 instances can be purchased as on-demand instances, reserved instances, or spot instances. High memory instances. Q. What are EC2 high memory instances? Amazon EC2 high memory instances offer 6 TB, 9 TB, 12 TB, 18 TB, or 24 TB of memory in a single instance. These instances are designed to run large in-memory databases, including production installations of SAP HANA, in the cloud. EC2 high memory instances with 6 TB, 9 TB, and 12 TB are powered by an 8-socket platform with Intel Xeon Platinum 8176M, Skylake processors. EC2 high memory instances with 18 TB and 24 TB are the first Amazon EC2 instances powered by an 8-socket platform with second-generation Intel Xeon Scalable, Cascade Lake, processors that are optimized for mission-critical enterprise workloads. EC2 high memory instances deliver high networking throughput and low latency with up to 100 gigabits per second of aggregate network bandwidth using Amazon Elastic Network Adapter, ENA, based enhanced networking. EC2 high memory instances are EBS optimized by default, and support encrypted and unencrypted EBS volumes. Q are high memory instances certified by SAP to run SAP HANA workloads. High memory instances are certified by SAP for running Business Suite on HANA, the next generation Business Suite S/4 HANA, Data Mart Solutions on HANA, Business Warehouse on HANA, and SAP BW/4 HANA in production environments. For details, see SAP's certified and supported SAP HANA hardware directory. Q, which instances are available within high memory instance category? 5 high memory instances are available. U6TB1.metal offers 6 TB memory, U9TB1.metal offers 9 TB memory, U12TB1.metal offers 12 TB memory, U18TB1.metal offers 18 TB memory, and U24TB1.metal offers 24 TB memory. Each high memory instance offers 448 logical processors, where each logical processor is a hyperthread on the 8-socket platform with total of 224 CPU cores. Q. What are the storage options available with high memory instances? High memory instances support Amazon EBS volumes for storage. High memory instances are EBS optimized by default, and offer up to 28 gigabits per second of storage bandwidth to both encrypted and unencrypted EBS volumes. Q. Which storage interface is supported on high memory instances? High memory instances access EBS volumes via PCI-attached NVM Express (NVM) interfaces. EBS volumes attached to high memory instances appear as NVM devices. NVM is an efficient and scalable storage interface, which is commonly used for flash-based SSDs and provides latency reduction and results in increased disk I/O and throughput. The EBS volumes are attached and detached by PCI hot plug. Q. What network performance is supported on high memory instances? High memory instances use the Elastic Network Adapter, ENA, for networking and enable enhanced networking by default. With ENA, high memory instances can utilize up to 100 gigabits per second of network bandwidth. Q. Can I run high memory instances in my existing Amazon Virtual Private Cloud, VPC? You can run high memory instances in your existing and new Amazon VPCs. Q. What is the underlying hypervisor on high memory instances? High memory instances are EC2 bare metal instances built on the AWS Nitro system, a rich collection of building blocks that offloads many of the traditional virtualization functions to dedicated hardware. These instances do not run on a hypervisor and allow the operating systems to run directly on the underlying hardware, while still providing access to the benefits of the cloud. Q. Do high memory instances enable CPU power management state control? Yes. You can configure C states and P states on high memory instances. You can use C states to enable higher turbo frequencies, as much as 4.0 GHz. You can also use P states to lower performance variability by pinning all cores at P1 or higher P states, which is similar to disabling turbo, and running consistently at the base CPU clock speed. Q. What purchase options are available for high memory instances? High memory instances are available on EC2 dedicated hosts on a 3-year reservation. After the 3-year reservation expires, you can continue using the host at an hourly rate or release at any time. Q. What is the life cycle of a dedicated host? Once a dedicated host is allocated within your account, it will be standing by for your use. You can then launch an instance with a tenancy of host using the Run Instances API, and can also stop/start/terminate the instance through the API. You can use the AWS Management Console to manage the dedicated host in the instance. The dedicated host will be allocated to your account for the period of 3-year reservation. After the 3-year reservation expires, you can continue using the host or release at any time. Q. Can I launch, stop/start, and terminate high memory instances using AWS CLI/SDK? You can launch, stop/start, and terminate instances on your EC2 dedicated hosts using AWS CLI/SDK. Q. Which AMIs are supported with high memory instances? EBS-backed HVM AMIs with support for ENA networking can be used with high memory instances. The latest Amazon Linux, Red Hat Enterprise Linux, SUSE Enterprise Linux Server, and Windows Server AMIs are supported. Operating system support for SAP HANA workloads on high memory instances include SUSE Linux Enterprise Server 12 SP3 for SAP, Red Hat Enterprise Linux 7.4 for SAP, Red Hat Enterprise Linux 7.5 for SAP, SUSE Linux Enterprise Server 12 SP4 for SAP, SUSE Linux Enterprise Server 15 for SAP, Red Hat Enterprise Linux 7.6 for SAP. Refer to SAP Certified and Supported SAP HANA Hardware Directory for latest detail on supported operating systems. Q. Are there standard SAP HANA reference deployment frameworks available for the high memory instance and the AWS cloud? You can use the AWS Quick Start Reference SAP HANA deployments to rapidly deploy all the necessary SAP HANA building blocks on high memory instances following SAP's recommendations for high performance and reliability. AWS Quick Starts are modular and customizable, so you can layer additional functionality on top or modify them for your own implementations. Previous generation instances. Q. Why don't I see M1, C1, CC2 and HS1 instances on the pricing pages anymore? These have been moved to the previous generation instance page. Q. Are these previous generation instances still being supported? Yes. Previous generation instances are still fully supported. Q. Can I still use /add more previous generation instances? Yes. Previous generation instances are still available as on-demand, reserved instances, and spot instance, from our APIs, CLI and EC2 Management Console interface. Q. Are my previous generation instances going to be deleted? No. Your C1, C3, CC2, CR1, G2, HS1, M1, M2, M3, R3 and T1 instances are still fully functional, and will not be deleted because of this change. Q. Are previous generation instances being discontinued soon? Currently, there are no plans to end-of-life previous generation instances. However, with any rapidly evolving technology, the latest generation will typically provide the best performance for the price, and we encourage our customers to take advantage of technological advancements. Q. Will my previous generation instances I purchased as a reserved instance be affected or changed? No. Your reserved instances will not change, and the previous generation instances are not going away. Memory optimized instances. Q. When should I use memory optimized instances? Memory optimized instances offer large memory size for memory intensive applications, including in-memory applications, in-memory databases, in-memory analytics solutions, high performance computing, HPC, scientific computing, and other memory intensive applications. Q. What are Amazon EC2 or 6G instances? Amazon EC2 or 6G instances are the next generation of memory optimized instances powered by ARM-based AWS Graviton2 processors. Our 6G instances deliver up to 40% better price performance over our 5 instances. They are built on the AWS Nitro system, a combination of dedicated hardware and Nitro hypervisor. Q. What are some of the ideal use cases for our 6G instances? Our 6G instances deliver significant price performance benefits for memory-intensive workloads such as instances and are ideal for running memory-intensive workloads such as open-source databases, in-memory caches, and real-time big data analytics. Customers deploying applications built on open-source software across the AR instance family will find the AR 6G instances an appealing option to realize the best price performance within the instance family. ARM developers can also build their applications directly on native ARM hardware as opposed to cross-compilation or emulation. Q. What are the various storage options available on our 6G instances? Our 6G instances are EBS optimized by default and offer up to 19,000 megabits per second of dedicated EBS bandwidth to both encrypted and unencrypted EBS volumes. Our 6G instances only support non-volatile memory express interface to access EBS storage volumes. Additionally, options with local instance storage are also available through the R6GD instance types. Q. Which network interface is supported on our 6G instances? Our 6G instances support ENA-based enhanced networking. With ENA, our 6G instances can deliver up to 25 gigabits per second of network bandwidth between instances when launched within a placement group. Q. Will customers need to modify their applications and workloads to be able to run on the R6G instances? The changes required are dependent on the application. Customers running applications built on open source software will find that the ARM ecosystem is well developed and already likely supports their applications. Most Linux distributions, as well as containers, Docker, Kubernetes, Amazon ECS, Amazon EKS, Amazon ECR, support the ARM architecture. Customers will find ARM versions of commonly used software packages available for installation through the same mechanisms that they currently use. Applications that are based on interpreted languages, such as Java, Node, Python, not reliant on native CPU instruction sets, should run with minimal to no changes. Applications developed using compiled languages, C, C++, Golang, will need to be recompiled to generate ARM binaries. The ARM architecture is well supported in these popular programming languages, and modern code usually requires a simple make command. Refer to the Getting Started guide on GitHub for more details. Q. Will there be more compute choices offered with the R6 instance families? Yes, we plan to offer Intel and AMD CPU-powered instances in the future as part of the R6 instance families. Q. What are Amazon EC2 or 5B instances? R5B instances are EBS-optimized variants of memory-optimized R5 instances that deliver up to 3x better EBS performance compared to same-sized R5 instances. R5B instances deliver up to 60 gigabits per second bandwidth and 260K IOPS of EBS performance, the fastest block storage performance on EC2. They are built on the AWS Nitro system, which is a combination of dedicated hardware and Nitro hypervisor. Q. What are some of the ideal use cases for R5B instances? R5B instances are ideal for large relational database workloads, including Microsoft SQL Server, SAP HANA, IBM DB2, and Oracle, that run performance-intensive applications such as commerce platforms, ERP systems, and health record systems. Customers looking to migrate large on-premises workloads with large storage performance requirements to AWS will find R5B instances to be a good fit. Q. What are the various storage options available on R5B instances? R5B instances are EBS optimized by default and offer up to 60,000 megabits per second of dedicated EBS bandwidth and 260K IOPS for both encrypted and unencrypted EBS volumes. R5B instances only support non-volatile memory express (NVMe) interface to access EBS storage volumes. R5B is supported by all volume types, with the exception of IO2 volumes. Q. When should I use R5B instances? Customers running workloads such as large relational databases and data analytics that want to take advantage of the increased EBS storage network performance can use R5B instances to deliver higher performance and bandwidth. Customer can also lower costs by migrating their workloads to smaller size R5B instances or by consolidating workloads on fewer R5B instances. Q. What are the storage options available with high memory instances? High memory instances support Amazon EBS volumes for storage. High memory instances are EBS optimized by default, and offer up to 38 gigabits per second of storage bandwidth to both encrypted and unencrypted EBS volumes. Q. What are Amazon EC2 X2GD instances? Amazon EC2 X2GD instances are the next generation of memory-optimized instances powered by AWS-designed ARM-based AWS Graviton2 processors. X2GD instances deliver up to 55% better price performance compared to current generation x86-based X1 instances and offer the lowest cost per gigabyte of memory in Amazon EC2. They are the first in the X family of instances to be built on the AWS Nitro system, which is a combination of dedicated hardware and Nitro hypervisor. Q. What workloads are suited for X2GD instances? X2GD is ideal for customers with ARM-compatible memory-bound scale-out workloads such as Redis and memcached in-memory databases that need low-latency memory access and benefit from more memory per CPU. X2GD is also well-suited for relational databases such as PostgreSQL, MariaDB, MySQL, and RDS Aurora. Customers who run memory-intensive workloads such as Apache Hadoop, real-time analytics, and real-time caching servers will benefit from 116 CPU to memory ratio of X2GD. Single-threaded workloads such as ADA backend verification jobs will benefit from physical core and more memory of X2GD instances, allowing them to consolidate more workloads onto a single instance. X2GD instance also feature local SSD block storage to improve response times by acting as a caching layer. Q. When should customer use X2GD instances compared to X1 in our family of instances? X2GD instances are suitable for ARM-compatible memory-bound scale-out workloads such as in-memory databases, memory analytics applications, open-source relational database workloads, ADA workloads, and large caching servers. X2GD instances offer customers the lowest cost per gigabyte of memory within EC2, with sizes up to 1 TB. X1 instances are suitable for memory-bound enterprise-class scale-up workloads that are generally dependent on x86 instruction sets such as Windows workloads, in-memory databases, for example, SAP HANA, and relational databases, for example, Oracle DB. Customers can leverage X1 family for larger memory sizes up to 4 TB. R6G and R6GD instances are suitable for workloads such as web applications, databases, and search indexing queries that need more FPUS during times of heavy data processing. Customers running memory-bound workloads that need less than 1 TB memory and have dependency on x86 instruction sets such as Windows applications, and legacy applications that run Oracle/SAP can leverage R5/R5D and R5A/R5AT instances, depending on their compute and cost requirements. Q. Which operating systems/AMIs are supported on X2GD instances? The following AMIs are supported: Amazon Linux 2, Ubuntu 18.04 or newer, Red Hat Enterprise Linux 8.2 or newer, and SUSE Enterprise Server 15 or newer. Customers will find additional AMIs such as Fedora, Debian, NetBSD, and CentOS available through Community AMIs and the AWS Marketplace. For containerized applications, Amazon ECS and EKS optimized AMIs are available as well. Q. When should I use X1 instances? X1 instances are ideal for running in-memory databases like SAP HANA, big data processing engines like Apache Spark or Presto, and high-performance computing (HPC) applications. X1 instances are certified by SAP to run production environments of the next-generation Business Suite S/4 HANA, Business Suite on HANA, SO, Business Warehouse on HANA, BW, and Data Mart Solutions on HANA on the AWS Cloud. Q. When should I use X1E instances? X1E instances are ideal for running in-memory databases like SAP HANA, high-performance databases and other memory-optimized enterprise applications. X1E instances offer twice the memory per CPU compared to the X1 instances. The X1E.32's large instance is certified by SAP to run production environments of the next-generation Business Suite S/4 HANA, Business Suite on HANA, SO, Business Warehouse on HANA, BW, and Data Mart Solutions on HANA on the AWS Cloud. Q. How do X1 and X1E instances differ? X1E instances offer 32 GB of memory per CPU whereas X1 instances offer 16 GB of memory per CPU. X1E instance sizes enable 6 instance configurations starting from 4 FPUS and 122 GB memory up to 128 FPUS and 3904 GB of memory. X1 instances enable 2 instance configurations, 64 FPUS with 976 GB memory and 128 FPUS with 1952 GB memory. Q. What are the key specifications of Intel E7, codenamed Haswell, processors that power X1 and X1E instances? The E7 processors have a high core count to support workloads that scale efficiently on large number of cores. The Intel E7 processors also feature high memory bandwidth and larger L3 caches to boost the performance of in-memory applications. In addition, the Intel E7 processor enables increased cryptographic performance via the latest Intel ISNI feature. Supports transactional synchronization extensions, TSX, to boost the performance of in-memory transactional data processing. Supports advanced vector extensions to Intel AVX2, processor instructions to expand most integer commands to 256 bits. Q. Do X1 and X1E instances enable CPU power management state control? Yes. You can configure C states and P states on X1E.32's large, X1E.16's large, X1E.8's large, X1.32's large and X1.16's large instances. You can use C states to enable higher turbo frequencies, as much as 3.1 GHz with 1 or 2 core turbo. You can also use P states to lower performance variability by pinning all cores at P1 or higher P states, which is similar to disabling turbo, and running consistently at the base CPU clock speed. Q. What operating systems are supported on X1 and X1E instances? X1 and X1E instances provide high number of FPUS, which might cause launch issues in some Linux operating systems that have a lower CPU limit. We strongly recommend that you use the latest AMIs when you launch these instances. AMI support for SAP HANA workloads include SUSE Linux 12, SUSE Linux 12 SP1, SULS for SAP 12 SP1, SULS for SAP 12 SP2, and RHEL 7.2 for SAP HANA. X1E.32's large will also support Windows Server 2012 R2 and 2012 RTM. X1E.extra large, X1E.2's large, X1E.4's large, X1E.8's large, X1E.16's large and X1.32's large will also support Windows Server 2012 R2, 2012 RTM and 2008 R2 64-bit, Windows Server 2008 SP2 and older versions will not be supported, and X1.16's large will support Windows Server 2012 R2, 2012 RTM, 2008 R2 64-bit, 2008 SP2 64-bit, and 2003 R2 64-bit. Windows Server 32-bit versions will not be supported. Q. What storage options are available for X1 customers? X1 instances offer SSD-based instance store, which is ideal for temporary storage of information such as logs, buffers, caches, temporary tables, temporary computational data, and other temporary content. X1 Instance Store provides the best I/O performance when you use a Linux kernel that supports persistent grants, an extension to the Xen block ring protocol. X1 instances are EBS optimized by default and offer up to 14 gigabits per second of dedicated bandwidth to EBS volumes. EBS offers multiple volume types to support a wide variety of workloads. For more information, see the EC2 user guide. Q. How do I build cost-effective failover solution on X1 and X1E instances? You can design simple and cost-effective failover solutions on X1 instances using Amazon EC2 Auto Recovery, an Amazon EC2 feature that is designed to better manage failover upon instance impairment. You can enable auto recovery for X1 instances by creating an AWS CloudWatch alarm. Choose the EC2 status check failed system metric and select the recover this instance action. Instance recovery is subject to underlying limitations, including those reflected in the instance recovery troubleshooting documentation. For more information, visit Auto Recovery Documentation and Creating Amazon CloudWatch Alarms respectively. Q. Are there standard SAP HANA reference deployment frameworks available for the high memory instance and the AWS cloud? You can use AWS Launch Wizard for SAP or AWS Quick Start Reference SAP HANA deployments to rapidly deploy all the necessary SAP HANA building blocks on high memory instances following recommendations from AWS and SAP for high performance and reliability. Storage optimized instances. Q. What is a dense storage instance? Dense storage instances are designed for workloads that require high sequential read and write access to very large data sets, such as Hadoop distributed computing, massively parallel processing data warehousing, and log processing applications. The dense storage instances offer the best price/GB storage and price/disk throughput across other EC2 instances. Q. How do dense storage instances compare to high I/O instances? High I/O instances, I2, I3, EN are targeted at workloads that demand low latency and high random I/O in addition to moderate storage density and provide the best price/IOPS across other EC2 instance types. Dense storage instances, D3, DIN, D2, and HDD storage instances, H1, are optimized for applications that require high sequential read/write access, and low-cost storage for very large data sets and provide the best price/GB storage and price/disk throughput across other EC2 instances. Q. How much disk throughput can dense storage and HDD storage instances deliver? The largest current generation of dense HDD storage instances, DIN.12's large, can deliver up to 6.2 GB per second read and 6.2 GB per second write disk throughput with a 128K block size. Please see the product detail page for additional performance information. To ensure the best disk throughput performance from your D2, D3 and DIN instances on Linux, we recommend that you use the most recent version of the Amazon Linux AMI, or another Linux AMI with a kernel version of 3.8 or later that supports persistent grants, an extension to the Xen block ring protocol that significantly improves disk throughput and scalability. Q. Do dense storage and HDD storage instances provide any failover mechanisms or redundancy? D2 and H1 instances provide notifications for hardware failures. Like all instance storage, dense HDD storage volumes persist only for the life of the instance. Hence, we recommend that you build a degree of redundancy, for example, RAID 1/5/6, or use file systems, for example, HDFS and MaperFS, that support redundancy and fault tolerance. You can also back up data periodically to more data storage solutions such as Amazon Elastic Block Store, EBS, or Simple Storage Service, S3. Q. How do dense HDD storage instances differ from Amazon EBS? Amazon EBS offers simple, elastic, reliable, replicated, and persistent block-level storage for Amazon EC2 while abstracting the details of the underlying storage media in use. Amazon EC2 instances with local HDD or NF storage provide directly attached, high-performance storage building blocks that can be used for a variety of storage applications. Dense storage instances are specifically targeted at customers who want high sequential read/write access to large data sets on local storage, for example, For Hadoop distributed computing and massively parallel processing data warehousing. Q. Can I launch dense HDD storage instances as Amazon EBS optimized instances? Each HDD storage instance type, H1, D2, D3, and DIN, is EBS optimized by default. Since this feature is always enabled, launching one of these instances explicitly as EBS optimized will not affect the instance's behavior. For more information on EBS optimized instances, see here. Q. Can I launch D2 instances as Amazon EBS optimized instances? Each D2 instance type is EBS optimized by default. D2 instances 500 megabits per second to 4000 megabits per second to EBS above and beyond the general purpose network throughput provided to the instance. Since this feature is always enabled on D2 instances, launching a D2 instance explicitly as EBS optimized will not affect the instance's behavior. Q. Are dense storage instances offered in EC2 Classic? The current generation of dense storage instances, D2 instances, can be launched in both EC2 Classic and Amazon VPC. However, by launching a dense storage instance into a VPC, you can leverage a number of features that are available only on the Amazon VPC platform, such as enabling enhanced networking, assigning multiple private IP addresses to your instances, or changing your instance's security groups. For more information about the benefits of using a VPC, see Amazon EC2 and Amazon Virtual Private Cloud, Amazon VPC. You can take steps to migrate your resources from EC2 Classic to Amazon VPC. For more information, see migrating a Linux instance from EC2 Classic to a VPC. Q. What is a high I/O instance? High I/O instances use base local instance storage to deliver very high, low latency, I/O capacity to applications, and are optimized for applications that require millions of IOPS. Like cluster instances, high I/O instances can be clustered via cluster placement groups for low latency networking. Q. Are all features of Amazon EC2 available for high I/O instances? High I/O instances support all Amazon EC2 features. i3 and EN instances offer only storage, while previous generation i2 instances allow legacy bookfront storage access. Currently you can only purchase high I/O instances as on-demand, reserved instances or as spot instances. Q. Is there a limit on the number of high I/O instances I can use? Currently, you can launch two i3.16's large instances by default. If you wish to run more than two on-demand instances, please complete the Amazon EC2 instance request form. Q. How many IOPS can i3.16. extra large instances deliver? Using HVM AMIs, high I/O i3 instances can deliver up to 3.3 million IOPS measured at 100% random reads using 4 kilobytes block size, and up to 300,000 100% random write IOPS, measured at 4 kilobytes block sizes to applications across 8 by 1.9 terabytes of devices. Q. What is the sequential throughput of i3 instances? The maximum sequential throughput, measured at 128K block sizes, is 16 GB per second read throughput and 6.4 GB per second write throughput. Q. AWS has other database and big data offerings. When or why should I use high I/O instances? High I/O instances are ideal for applications that require access to millions of low latency IOPS, and can leverage data stores and architectures that manage data redundancy and availability. Example applications are NoSQL databases like Cassandra and MongoDB, and memory databases like Aerospike, Elasticsearch, and analytics workloads OLTP systems. Q. Do high I/O instances provide any failover mechanisms or redundancy? Like other Amazon EC2 instance types, instance storage on i3 and EN instances persists during the life of the instance. Customers are expected to build resilience into their applications. We recommend using databases and file systems that support redundancy and fault tolerance. Customers should back up data periodically to Amazon S3 for improved data durability. Q. Do high I/O instances support trim? The trim command allows the operating system to inform SSDs which blocks of data are no longer considered in use and can be wiped internally. In the absence of trim, future write operations to the involved blocks can slow down significantly. i3 and EN instances support trim. Q. How many IOPS can EN.24's large instances deliver? Using HVM AMIs, high I/O EN instances can deliver up to 2 million IOPS measured at 100% random reads using 4 kilobytes block sizes, and up to 1.6 million 100% random write IOPS, measured at 4 kilobytes block sizes to applications across 8 by 7.5 terabytes of devices. Q. What is the sequential throughput of EN instances? The maximum sequential throughput, measured at 128K block sizes is 16 GB per second read throughput and 8 GB per second write throughput. Q. How do D3 and DIN instances compare to D2 instances? D3 and DIN instances offer improved specifications over D2 on the following compute, storage and network attributes. D3 and DIN instances offer up to 30% higher compute performances than equivalent D2 instances. Exact performance benefit will depend on the specific workload. D3 and DIN instances provide up to 45% and 100% higher disk throughput than D2 instances, respectively. D3 instances are available at a price that is 5% lower than D2 instances. DIN instances lower cost per terabyte of storage by up to 80% compared to D2 instances. D3 and DIN instances offer Intel Advanced Vector Extensions, AVX 512, which offer up to 2x the flops per cycle compared to AVX2 on D2. DIN instances offer a new instance size, 12XL, with 48 PIS and 7 TB of storage per CPU for 336 TB of total storage, but have half the memory per CPU compared to D2 and 48 TB of total storage. D3 and DIN instances offer up to 25 gigabits per second and 75 gigabits per second of network bandwidth respectively on their largest sizes to meet customer needs for network performance for running big data workloads and file system clusters. Q. Do D3 and DIN instances encrypt storage volumes and network traffic? Yes, data written onto the storage volumes will be encrypted at rest using ISE 256XTS. Network traffic between D3 and DIN instances in the same VPC or a peered VPC are encrypted by default using a 256-bit key. Storage Amazon Elastic Block Store, EBS. Q. What happens to my data when a system terminates? The data stored on a local instance store will persist only as long as that instance is alive. However, data that is stored on an Amazon EBS volume will persist independently of the life of the instance. Therefore, we recommend that you use the local instance store for temporary data and, for data requiring a higher level of durability, we recommend using Amazon EBS volumes or backing up the data to Amazon S3. If you are using an Amazon EBS volume as a root partition, you will need to set the delete on terminate flag to N if you want your Amazon EBS volume to persist outside the life of the instance. Q. What kind of performance can I expect from Amazon EBS volumes? Amazon EBS provides 4 current generation volume types, and are divided into 2 major categories, SSD-backed storage for transactional workloads and HDD-backed storage for throughput-intensive workloads. These volume types differ in performance characteristics and price, allowing you to tailor your storage performance and cost to the needs of your applications. For more information on see the EBS product details page, and for additional information on performance, see the Amazon EC2 User Guides EBS Performance section. Q. What are throughput-optimized HDD, ST1, and cold HDD, SC1 volume types? ST1 volumes are backed by hard disk drives, HDDs, and are ideal for frequently accessed, throughput-intensive workloads with large datasets and large I/O sizes, such as MapReduce, Kafka, log processing, data warehouse, and ETL workloads. These volumes deliver performance in terms of throughput, measured in MB/s, and include the ability to burst up to 250 megabytes per second per terabyte, with a baseline throughput of 40 megabytes per second per terabyte and a maximum throughput of 500 megabytes per second per volume. ST1 is designed to deliver the expected throughput performance 99% of the time and has enough I/O credits to support a full volume scan at the burst rate. SC1 volumes are backed by hard disk drives, HDDs, and provides the lowest cost per gigabyte of all EBS volume types. It is ideal for less frequently accessed workloads with large, cold datasets. Similar to SD1, SC1 provides a burst model. These volumes can burst up to 80 megabytes per second per terabyte, with a baseline throughput of 12 megabytes per second per terabyte and a maximum throughput of 250 megabytes per second per volume. For infrequently accessed data, SC1 provides extremely inexpensive storage. SC1 is designed to deliver the expected throughput performance 99% of the time and has enough I/O credits to support a full volume scan at the burst rate. To maximize the performance of ST1 and SC1, we recommend using EBS optimized EC2 instances. Q. Which volume type should I choose? Amazon EBS includes 2 major categories of storage: SSD-backed storage for transactional workloads, performance depends primarily on IOPS, and HDD-backed storage for throughput workloads, performance depends primarily on throughput, measured in MB/s. SSD-backed volumes are designed for transactional, IOPS-intensive database workloads, boot volumes, and workloads that require high IOPS. SSD-backed volumes include provisioned IOPS SSD, IO1 and IO2, and general-purpose SSD, GP2 and GP3. HDD-backed volumes are designed for throughput-intensive and big data workloads, large I/O sizes, and sequential I/O patterns. HDD-backed volumes include throughput-optimized HDD ST1 and cold HDD SC1. For more information on Amazon EBS, see the EBS product details page. Q. Do you support multiple instances accessing a single volume? Yes, you can enable multi-attach on an EBS provisioned IOPS IO1 volume to allow a volume to be concurrently attached to up to 16 Nitro-based EC2 instances within the same availability zone. For more information on Amazon EBS multi-attach, see the EBS product page. Q. Will I be able to access my EBS snapshots using the regular Amazon S3 APIs? No, EBS snapshots are only available through the Amazon EC2 APIs. Q. Do volumes need to be unmounted in order to take a snapshot? Does the snapshot need to complete before the volume can be used again? No, snapshots can be done in real time while the volume is attached and in use. However, snapshots only capture data that has been written to your Amazon EBS volume, which might exclude any data that has been locally cached by your application or OS. In order to ensure consistent snapshots on volumes attached to an instance, we recommend cleanly detaching the volume, issuing the snapshot command, and then reattaching the volume. For Amazon EBS volumes that serve as root devices, we recommend shutting down the machine to take a clean snapshot. Q. Are snapshots versioned? Can I read an older snapshot to do a point-in-time recovery? Each snapshot is given a unique identifier, and customers can create volumes based on any of their existing snapshots. Q. What charges apply when using Amazon EBS shared snapshots? If you share a snapshot, you won't be charged when other users make a copy of your snapshot. If you make a copy of another user's shared volume, you will be charged normal EBS rates. Q. Can users of my Amazon EBS shared snapshots change any of my data? Users who have permission to create volumes based on your shared snapshots will first make a copy of the snapshot into their account. Users can modify their own copies of the data, but the data on your original snapshot and any other volumes created by other users from your original snapshot will remain unmodified. Q. How can I discover Amazon EBS snapshots that have been shared with me? You can find snapshots that have been shared with you by selecting Private Snapshots from the Viewing dropdown in the Snapshots section of the AWS Management Console. This section will list both snapshots you own and snapshots that have been shared with you. Q. How can I find what Amazon EBS snapshots are shared globally? You can find snapshots that have been shared globally by selecting Public Snapshots from the Viewing dropdown in the Snapshots section of the AWS Management Console. Q. Do you offer encryption on Amazon EBS volumes and snapshots? Yes. EBS offers seamless encryption of data volumes and snapshots. EBS encryption better enables you to meet security and encryption compliance requirements. Q. How can I find a list of Amazon public datasets? All information on public datasets is available in our Public Datasets Resource Center. You can also obtain a listing of public datasets within the AWS Management Console by choosing Amazon Snapshots from the Viewing dropdown in the Snapshots section. Q. Where can I learn more about EBS? You can visit the Amazon EBS FAQ page. Amazon Elastic File System, EFS. Q. How do I access a file system from an Amazon EC2 instance? To access your file system, you mount the file system on an Amazon EC2 Linux-based instance using the standard Linux mount command and the file system's DNS name. Once you've mounted, you can work with the files and directories in your file system just like you would with a local file system. Amazon EFS uses the NFS v4.1 protocol. For a step-by-step example of how to access a file system from an Amazon EC2 instance, please see the Amazon EFS Getting Started guide. Q. What Amazon EC2 instance types and AMIs work with Amazon EFS? Amazon EFS is compatible with all Amazon EC2 instance types and is accessible from Linux-based AMIs. You can mix and match the instance types connected to a single file system. For a step-by-step example of how to access a file system from an Amazon EC2 instance, please see the Amazon EFS Getting Started guide. Q. How do I load data into a file system? You can load data into an Amazon EFS file system from your Amazon EC2 instances or from your on-premises data center servers. Amazon EFS file systems can be mounted on an Amazon EC2 instance, so any data that is accessible to an Amazon EC2 instance can also be read and written to Amazon EFS. To load data that is not currently stored on the Amazon cloud, you can use the same methods you use to transfer files to Amazon EC2 today, such as Secure Copy (SCP). Amazon EFS file systems can also be mounted on an on-premises server, so any data that is accessible to an on-premises server can be read and written to Amazon EFS using standard Linux tools. For more information about accessing a file system from an on-premises server, please see the On-Premises Access section of the Amazon EFS FAQ. For more information about moving data to the Amazon cloud, please see the Cloud Data Migration page. Q. How do I access my file system from outside my VPC? Amazon EC2 instances within your VPC can access your file system directly, and Amazon EC2 Classic instances outside your VPC can mount a file system via Classic Link. On-premises servers can mount your file systems via an AWS Direct Connect connection to your VPC. Q. How many Amazon EC2 instances can connect to a file system? Amazon EFS supports 1 to thousands of Amazon EC2 instances connecting to a file system concurrently. Q. Where can I learn more about EFS? You can visit the Amazon EFS FAQ page. VIM Instance Storage Queue. Which instance types offer VIM instance storage? Today, EN, i3, C6GD, C5D, C5AD, M6GD, M5D, M5DN, M5AD, R6GD, R5D, R5DN, R5AD, Z1D head, G4DN, and F1, X1, X1E instances offer VIM instance storage. Q. Is data stored on Amazon EC2 VIM instance storage encrypted? Yes, all data is encrypted in an AWS Nitro hardware module prior to being written on the locally attached SSDs offered via VIM instance storage. Q. What encryption algorithm is used to encrypt Amazon EC2 VIM instance storage? Amazon EC2 VIM instance storage is encrypted using an XDSI's 256-block cipher. Q. Are encryption keys unique to an instance or a particular device for VIM instance storage? Encryption keys are securely generated within the Nitro hardware module, and are unique to each VIM instance storage device that is provided with an EC2 instance. Q. What is the lifetime of encryption keys on VIM instance storage? All keys are irrecoverably destroyed on any deallocation of the storage, including instance stop and instance terminate actions. Q. Can I disable VIM instance storage encryption? No, VIM instance storage encryption is always on, and cannot be disabled. Q. Do the published IOPS performance numbers on i3 and EN include data encryption? Yes, the documented IOPS numbers for i3 and EN VIM instance storage include encryption. Q. Does Amazon EC2 VIM instance storage support AWS Key Management Service, KMS? No, disk encryption on VIM instance storage does not support integration with AWS KMS system. Customers cannot bring in their own keys to use with VIM instance storage. Networking and Security Elastic Fabric Adapter, EFAQ. Why should I use EFA? EFA brings the scalability, flexibility, and elasticity of cloud to tightly coupled HPC applications. With EFA, tightly coupled HPC applications have access to lower and more consistent latency and higher throughput than traditional TCP channels, enabling them to scale better. EFA support can be enabled dynamically, on demand on any supported EC2 instance without pre-reservation, giving you the flexibility to respond to changing business/workload priorities. Q. What types of applications can benefit from using EFA? High-performance computing, HPC, applications distribute computational workloads across a cluster of instances for parallel processing. Examples of HPC applications include computational fluid dynamics, CFD, crash simulations, and weather simulations. HPC applications are generally written using the Message Passing Interface, MPI, and impose stringent requirements for inter-instance communication in terms of both latency and bandwidth. Applications using MPI and other HPC middleware which supports the libfabric communication stack can benefit from EFA. Q. How does EFA communication work? EFA devices provide all ENA devices functionalities plus a new OS bypass hardware interface that allows user space applications to communicate directly with the hardware provided reliable transport functionality. Most applications will use existing middleware, such as the Message Passing Interface, MPI, to interface with EFA. AWS has worked with a number of middleware providers to ensure support for the OS bypass functionality of EFA. Please note that communication using the OS bypass functionality is limited to instances within a single subnet of a virtual private cloud, VPC. Q. Which instance types support EFA? EFA is currently available on the M5N.24's large, M5DN.24's large, M5N.metal, M5DN.metal, R5N.24s large, R5DN.24s large, R5N.metal, R5DN.metal, C5N.18s large, C5N.metal, PEDN.24s large, EN.24s large, and EN.metal instance sizes. Support for more instance types and sizes being added in the coming months. Q. What are the differences between an FA-NE and an ENA-NE? An ENA-NE provides traditional IP networking features necessary to support VPC networking. An FA-NE provides all the functionality of an ENA-NE, plus hardware support for applications to communicate directly with the FA-NE without involving the instance kernel, OS bypass communication, using an extended programming interface. Due to the advanced capabilities of the FA-NE, FA-NEs can only be attached at launch or to stopped instances. Q. What are the prerequisites to enabling FA on an instance? FA support can be enabled either at the launch of the instance or added to a stopped instance. FA devices cannot be attached to a running instance. Elastic IPQ. Why am I limited to 5 elastic IP addresses per region? Public, IPv4 internet addresses are a scarce resource. There is only a limited amount of public IP space available, and Amazon EC2 is committed to helping use that space efficiently. By default, all accounts are limited to 5 elastic IP addresses per region. If you need more than 5 elastic IP addresses, we ask that you apply for your limit to be raised. We will ask you to think through your use case and help us understand your need for additional addresses. You can apply for more elastic IP address here. Any increases will be specific to the region they have been requested for. Q. Why am I charged when my elastic IP address is not associated with a running instance? In order to help ensure our customers are efficiently using the elastic IP addresses, we impose a small hourly charge for each address when it is not associated to a running instance. Q. Do I need one elastic IP address for every instance that I have running? No. You do not need an elastic IP address for all your instances. By default, every instance comes with a private IP address and an internet routable public IP address. The private IP address remains associated with the network interface when the instance is stopped and restarted, and is released when the instance is terminated. The public address is associated exclusively with the instance until it is stopped, terminated or replaced with an elastic IP address. These IP addresses should be adequate for many applications where you do not need a long-lived internet routable endpoint. Compute clusters, web crawling, and backend services are all examples of applications that typically do not require elastic IP addresses. Q. How long does it take to remap an elastic IP address? The remap process currently takes several minutes from when you instruct us to remap the elastic IP until it fully propagates through our system. Q. Can I configure the reverse DNS record for my elastic IP address? All elastic IP addresses come with reverse DNS, in a standard template of the form ec21234.region.compute.amazonos.com. For customers requiring custom reverse DNS settings for internet-facing applications that use IP-based mutual authentication, such as sending email from EC2 instances, you can configure the reverse DNS record of your elastic IP address by filling out this form. Alternatively, please contact AWS customer support if you want AWS to delegate the management of the reverse DNS for your elastic IPs to your authoritative DNS name servers, such as Amazon Route 53, so that you can manage your own reverse DNS PTR records to support these use cases. Note that a corresponding forward DNS record pointing to that elastic IP address must exist before we can create the reverse DNS record. Elastic Load Balancing Queue. What load balancing options does the Elastic Load Balancing service offer? Elastic Load Balancing offers 2 types of load balancers that both feature high availability, automatic scaling, and robust security. These include the classic load balancer that routes traffic based on either application or network level information, and the application load balancer that routes traffic based on advanced application level information that includes the content of the request. Q. When should I use the classic load balancer and when should I use the application load balancer? The classic load balancer is ideal for simple load balancing of traffic across multiple EC2 instances, while the application load balancer is ideal for applications needing advanced routing capabilities, microservices, and container-based architectures. Please visit Elastic Load Balancing for more information. Enhanced Networking Queue. What networking capabilities are included in this feature? We currently support enhanced networking capabilities using SRIOV, Single Root I/O Virtualization. SRIOV is a method of device virtualization that provides higher I/O performance and lower CPU utilization compared to traditional implementations. For supported Amazon EC2 instances, this feature provides higher packet per second, PPS, performance, lower inter-instance latencies, and very low network jitter. Q. Why should I use enhanced networking? If your applications benefit from high packet per second performance and/or low latency networking, enhanced networking will provide significantly improved performance, consistency of performance and scalability. Q. How can I enable enhanced networking on supported instances? In order to enable this feature, you must launch an HVM AMI with the appropriate drivers. C5, C5D, F1, G3, H1, I3, EN, D3, DEN, M4.16s large, M5, M5A, M5AD, M5D, P2, P3, R4, R5, R5A, R5AD, R5D, T3E, X1, X1E, and Z1D instances use the Elastic Network Adapter, which uses the ENA Linux driver for enhanced networking. C3, C4, D2, I2, M4, excluding M4.16s large, and R3 instances use Intel 82599 grams virtual function interface, which uses the XBEF Linux driver. Amazon Linux AMI includes both of these drivers by default. For AMIs that do not contain these drivers, you will need to download and install the appropriate drivers based on the instance types you plan to use. You can use Linux or Windows instructions to enable enhanced networking in AMIs that do not include the SRIOV driver by default. Enhanced networking is only supported in Amazon VPC. Q. Do I need to pay an additional fee to use enhanced networking? No, there is no additional fee for enhanced networking. To take advantage of enhanced networking, you need to launch the appropriate AMI on a supported instance type in a VPC. Q. Why is enhanced networking only supported in Amazon VPC? Amazon VPC allows us to deliver many advanced networking features to you that are not possible in EC2 Classic. Enhanced networking is another example of a capability enabled by Amazon VPC. Q. Which instance types support enhanced networking? Depending on your instance type, enhanced networking can be enabled using one of the following mechanisms: Intel 82599 Virtual Function (VF) interface. The Intel 82599 Virtual Function interface supports network speeds of up to 10 gigabits per second for supported instance types. C3, C4, D2, I2, M4, excluding M4.16s large, and R3 instances use the Intel 82599 VF interface for enhanced networking. Elastic Network Adapter, ENA. The Elastic Network Adapter, ENA, supports network speeds of up to 25 gigabits per second for supported instance types. C5, C5D, F1, G3, H1, I3, EN, D3, DEN, M4.16s large, M5, M5A, M5AD, M5D, M5ZN, P2, T3, R4, R5, R5A, R5AD, R5D, T3, X1, X1E, and Z1D instances use the Elastic Network Adapter for enhanced networking. Q. Which instance types offer instance storage? High I/O instances use base local instance storage to deliver very high, low latency, I/O capacity to applications, and are optimized for applications that require millions of IOPS. Like cluster instances, high I/O instances can be clustered via cluster placement groups for high bandwidth networking. Security. Q. How do I prevent other people from viewing my systems? You have complete control over the visibility of your systems. The Amazon EC2 security systems allow you to place your running instances into arbitrary groups of your choice. Using the Web Services interface, you can then specify which groups may communicate with which other groups, and also which IP subnets on the internet may talk to which groups. This allows you to control access to your instances in our highly dynamic environment. Of course, you should also secure your instance as you would any other server. Q. Can I get a history of all EC2 API calls made on my account for security analysis and operational troubleshooting purposes? Yes. To receive a history of all EC2 API calls, including VPC and EBS, made on your account, you simply turn on CloudTrail in the AWS Management Console. For more information, visit the CloudTrail homepage. Q. Where can I find more information about security on AWS? For more information on security on AWS, please refer to our Amazon Web Services, Overview of Security Processes white paper and to our Amazon EC2 Running Windows Security Guide. Management. Amazon CloudWatch. Q. What is the minimum time interval granularity for the data that Amazon CloudWatch receives in aggregates? Metrics are received and aggregated at 1-minute intervals. Q. Which operating systems does Amazon CloudWatch support? Amazon CloudWatch receives and provides metrics for all Amazon EC2 instances and should work with any operating system currently supported by the Amazon EC2 service. Q. Will I lose the metrics data if I disable monitoring for an Amazon EC2 instance? You can retrieve metrics data for any Amazon EC2 instance up to 2 weeks from the time you started to monitor it. After 2 weeks, metrics data for an Amazon EC2 instance will not be available if monitoring was disabled for that Amazon EC2 instance. If you want to archive metrics beyond 2 weeks, you can do so by calling moan-get-stats command from the command line and storing the results in Amazon S3 or Amazon SimpleDB. Q. Can I access the metrics data for a terminated Amazon EC2 instance or a deleted Elastic Load Balancer? Yes. Amazon CloudWatch stores metrics for terminated Amazon EC2 instances or deleted Elastic Load Balancers for 2 weeks. Q. Does the Amazon CloudWatch monitoring charge change depending on which type of Amazon EC2 instance I monitor? No, the Amazon CloudWatch monitoring charge does not vary by Amazon EC2 instance type. Q. Why does the graphing of the same time window look different when I view in 5-minute and 1-minute periods? If you view the same time window in a 5-minute period versus a 1-minute period, you may see that data points are displayed in different places on the graph. For the period you specify in your graph, Amazon CloudWatch will find all the available data points and calculates a single, aggregate point to represent the entire period. In the case of a 5-minute period, the single data point is placed at the beginning of the 5-minute time window. In the case of a 1-minute period, the single data point is placed at the 1-minute mark. We recommend using a 1-minute period for troubleshooting and other activities that require the most precise graphing of time periods. Amazon EC2 Auto-Scaling Q. Can I automatically scale Amazon EC2 auto-scaling groups? Yes. Amazon EC2 auto-scaling is a fully managed service designed to launch or terminate Amazon EC2 instances automatically to help ensure you have the correct number of Amazon EC2 instances available to handle the load for your application. EC2 auto-scaling helps you maintain application availability through fleet management for EC2 instances, which detects and replaces unhealthy instances, and by scaling your Amazon EC2 capacity up or down automatically according to conditions you define. You can use EC2 auto-scaling to automatically increase the number of Amazon EC2 instances during demand spikes to maintain performance and decrease capacity during lulls to reduce costs. Allocation strategies in EC2 auto-scaling determines how spot instances in your fleet are fulfilled from spot instance pools. The capacity-optimized allocation strategy attempts to provision spot instances from the most available spot instance pools by analyzing capacity metrics. This strategy is a good choice for workloads that have a higher cost of interruption such as big data and analytics, image and media rendering, machine learning, and high-performance computing. The lowest price allocation strategy launches spot instances strictly based on diversification across and lowest priced pools. For more information, see the Amazon EC2 auto-scaling FAQ. Hibernate Q. Why should I hibernate an instance? You can hibernate an instance to get your instance and applications up and running quickly, if they take long time to bootstrap, for example load memory caches. You can start instances, bring them to a desired state and hibernate them. These pre-warmed instances can then be resumed to reduce the time it takes for an instance to return to service. Hibernation retains memory state across stop/start cycles. Q. What happens when I hibernate my instance? When you hibernate an instance, data from your EBS root volume and any attached EBS data volumes is persisted. Additionally, contents from the instance's memory, RAM, are persisted to EBS root volume. When the instance is restarted, it returns to its previous state and reloads the RAM contents. Q. What is the difference between hibernate and stop? In the case of hibernate, your instance gets hibernated and the RAM data persisted. In the case of stop, your instance gets shut down and RAM is cleared. In both the cases, data from your EBS root volume and any attached EBS data volumes is persisted. Your private IP address remains the same, as does your elastic IP address, if applicable. The network layer behavior will be similar to that of EC2 stop-start workflow. Stop and hibernate are available for Amazon EBS-backed instances only. Local instance storage is not persisted. Q. How much does it cost to hibernate an instance? Hibernating instances are charged at standard EBS rates for storage. As with a stopped instance, you do not incur instance usage fees while an instance is hibernating. Q. How can I hibernate an instance? Hibernation needs to be enabled when you launch the instance. Once enabled, you can use the Stop Instances API with an additional Hibernate parameter to trigger hibernation. You can also do this through the console by selecting your instance, then clicking Actions Instance State greater than Stop, Hibernate. For more information on using hibernation, refer to the user guide. Q. How can I resume a hibernating instance? You can resume by calling the Start Instances API as you would for a regular stopped instance. You can also do this through the console by selecting your instance, then clicking Actions greater than Instance State greater than Start Q. Can I enable hibernation on an existing instance? No, you cannot enable hibernation on an existing instance, running or stopped. This needs to be enabled during instance launch. Q. How can I tell that an instance is hibernated? You can tell that an instance is hibernated by looking at the state reason. It should be client.user-initiated hibernate. This is visible on the console under Instances, Details View or in the Describe Instances API Responses reason field. Q. What is the state of an instance when it is hibernating? Hibernated instances are in stop state. Q. What data is saved when I hibernate an instance? EBS volume storage, boot volume and attached data volumes, and memory, RAM, are saved. Your private IP address remains the same, for VPC, as does your elastic IP address, if applicable. The network layer behavior will be similar to that of EC2 stop-start workflow. Q. Where is my data stored when I hibernate an instance? As with the stop feature, root device and attached device data are stored on the corresponding EBS volumes. Memory, RAM, contents are stored on the EBS root volume. Q. Is my memory, RAM, data encrypted when it is moved to EBS? Yes, RAM data is always encrypted when it is moved to the EBS root volume. Encryption on the EBS root volume is enforced at instance launch time. This is to ensure protection for any sensitive content that is in memory at the time of hibernation. Q. How long can I keep my instance hibernated? We do not support keeping an instance hibernated for more than 60 days. You need to resume the instance and go through stop and start, without hibernation, if you wish to keep the instance around for a longer duration. We are constantly working to keep our platform up to date with upgrades and security patches, some of which can conflict with the old hibernated instances. We will notify you for critical updates that require you to resume the hibernated instance to perform a shutdown or a reboot. Q. What are the prerequisites to hibernate an instance? To use hibernation, the root volume must be an encrypted EBS volume. The instance needs to be configured to receive the ASPID signal for hibernation, or use the Amazon published AMIs that are configured for hibernation. Additionally, your instance should have sufficient space available on your EBS root volume to write data from memory. Q. Which instances and operating systems support hibernation? Hibernation is currently supported across C3, C4, C5, I3, M3, M4, M5, M5A, M5AD, R3, R4, R5, R5A, R5AD, T2, T3, and T instances running Amazon Linux, Amazon Linux 2, Ubuntu and Windows. For Windows, hibernation is supported for instances up to 16 GB of RAM. For other operating systems, hibernation is supported for instances with less than 150 GB of RAM. To review the list of supported OS versions, refer to the user guide. Q. Should I use specific Amazon Machine Image, AMIs, if I want to hibernate my instance? You can use any AMI that is configured to support hibernation. You can use AWS published AMIs that support hibernation by default. Alternatively, you can create a custom image from an instance after following the hibernation prerequisite checklist and configuring your instance appropriately. Q. What if my EBS root volume is not large enough to store memory state, RAM, for hibernate? To enable hibernation, space is allocated on the root volume to store the instance memory, RAM. Make sure that the root volume is large enough to store the RAM contents and accommodate your expected usage, for example, OS, applications. If the EBS root volume does not enough space, hibernation will fail and the instance will get shut down instead. VM import/export Q. What is VM import/export? VM import/export enables customers to import virtual machine VM images in order to create Amazon EC2 instances. Customers can also export previously imported EC2 instances to create VMs. Customers can use VM import/export to leverage their previous investments in building VMs by migrating their VMs to Amazon EC2. Q. What operating systems are supported? VM import/export currently supports Windows and Linux VMs, including Windows Server 2003, Windows Server 2003 R2, Windows Server 2008, Windows Server 2012 R1, Red Hat Enterprise Linux, RHEL, 5.1 to 6.5, using Cloud Access, CentOS 5.1 to 6.5, Ubuntu 12.04, 12.10, 13.04, 13.10, and Debian 6.0.0 to 6.0.8, 7.0.0 to 7.2.0. For more details on VM import, including supported file formats, architectures, and operating system configurations, please see the VM import/export section of the Amazon EC2 user guide. Q. What virtual machine file formats are supported? You can import VMware ESX VMDK images, Citrix and VHD images, Microsoft Hyper-V VHD images and RAW images as Amazon EC2 instances. You can export EC2 instances to VMware ESX VMDK, VMware ESX OVA, Microsoft Hyper-V VHD or Citrix and VHD images. For a full list of support operating systems, please see what operating systems are supported. Q. What is VMDK? VMDK is a file format that specifies a virtual machine hard disk encapsulated within a single file. It is typically used by virtual IT infrastructures such as those sold by VMware Incorporated. Q. How do I prepare a VMDK file for import using the VMware vSphere client? The VMDK file can be prepared by calling file export to OVF template in VMware vSphere client. The resulting VMDK file is compressed to reduce the image size and is compatible with VM import/export. No special preparation is required if you are using the Amazon EC2 VM Import Connector vApp for VMware vCenter. Q. What is VHD? VHD, Virtual Hard Disk, is a file format that specifies a virtual machine hard disk encapsulated within a single file. The VHD image format is used by virtualization platforms such as Microsoft Hyper-V and Citrix Zen. Q. How do I prepare a VHD file for import from Citrix Zen? Open Citrix Zen Center and select the virtual machine you want to export. Under the Tools menu, choose Virtual Appliance Tools and select Export Appliance to initiate the export task. When the export completes, you can locate the VHD image file in the destination directory you specified in the export dialog. Q. How do I prepare a VHD file for import from Microsoft Hyper-V? Open the Hyper-V Manager and select the virtual machine you want to export. In the Actions pane for the virtual machine, select Export to initiate the export task. Once the export completes, you can locate the VHD image file in the destination directory you specified in the export dialog. Q. Are there any other requirements when importing a VM into Amazon EC2? The virtual machine must be in a stop state before generating the VMDK or VHD image. The VM cannot be in a paused or suspended state. We suggest that you export the virtual machine with only the boot volume attached. You can import additional disks using the import volume command and attach them to the virtual machine using attach volume. Additionally, encrypted disks, for example, BitLocker, and encrypted image files are not supported. You are also responsible for ensuring that you have all necessary rights and licenses to import into AWS and run any software included in your VM image. Q. Does the virtual machine need to be configured in any particular manner to enable import to Amazon EC2? Ensure Remote Desktop, RDP, or Secure Shell, SSH, is enabled for remote access and verify that your host firewall, Windows Firewall, Iptables, or similar, if configured, allows access to RDP or SSH. Otherwise, you will not be able to access your instance after the import is complete. Please also ensure that Windows VMs are configured to use strong passwords for all users including the administrator and that Linux VMs are configured with a public key for SSH access. Q. How do I import a virtual machine to an Amazon EC2 instance? You can import your VM images using the Amazon EC2 API tools, import the VMDK, VHD or RAW file via the EC2 Import Instance API. The import instance task captures the parameters necessary to properly configure the Amazon EC2 instance properties. Instance size, availability zone, and security groups, and uploads the disk image into Amazon S3. If EC2 import instance is interrupted or terminates without completing the upload, use EC2 resume import to resume the upload. The import task will resume where it left off. Use the EC2 describe conversion task command to monitor the import progress and obtain the resulting Amazon EC2 instance ID. Once your import task is completed, you can boot the Amazon EC2 instance by specifying its instance ID to the EC2 Run Instances API. Finally, use the EC2 delete disk image command line tool to delete your disk image from Amazon S3 as it is no longer needed. Alternatively, if you use the VMware vSphere virtualization platform, you can import your virtual machine to Amazon EC2 using a graphical user interface provided through AWS Management Portal for vCenter. Please refer to Getting Started Guide in AWS Management Portal for vCenter. AWS Management Portal for vCenter includes integrated support for VM import. Once the portal is installed within vCenter, you can right-click on a VM and select Migrate to EC2 to create an EC2 instance from the VM. The portal will handle exporting the VM from vCenter, uploading it to S3 and converting it into an EC2 instance for you, with no additional work required. You can also track the progress of your VM migrations within the portal. Q. How do I export an Amazon EC2 instance back to my on-premise virtualization environment? You can export your Amazon EC2 instance using the Amazon EC2 CLI tools. Export the instance using the EC2 create instance export task command. The export command captures the parameters necessary: instance ID S3 bucket to hold the exported image, name of the exported image, VMDK, OVA or VHD format, to properly export the instance to your chosen format. The exported file is saved in an S3 bucket that you previously created. Use EC2 describe export task to monitor the export progress. Use EC2 cancel export task to cancel an export task prior to completion. Q. Are there any other requirements when exporting an EC2 instance using VM import/export? You can export running or stopped EC2 instances that you previously imported using VM import/export. If the instance is running, it will be momentarily stopped to snapshot the boot volume. EBS data volumes cannot be exported. EC2 instances with more than one network interface cannot be exported. Q. Can I export Amazon EC2 instances that have one or more EBS data volumes attached? Yes, but VM import/export will only export the boot volume of the EC2 instance. Q. What does it cost to import a virtual machine? You will be charged standard Amazon S3 data transfer and storage fees for uploading and storing your VM image file. Once your VM is imported, standard Amazon EC2 instance hour and EBS service fees apply. If you no longer wish to store your VM image file in S3 after the import process completes, use the EC2 delete disk image command line tool to delete your disk image from Amazon S3. Q. What does it cost to export a virtual machine? You will be charged standard Amazon S3 storage fees for storing your exported VM image file. You will also be charged standard S3 data transfer charges when you download the exported VM file to your on-premise virtualization environment. Finally, you will be charged standard EBS charges for storing a temporary snapshot of your EC2 instance. To minimize storage charges, delete the VM image file in S3 after downloading it to your virtualization environment. Q. When I import a VM of Windows Server 2003 or 2008, who is responsible for supplying the operating system license? When you launch an imported VM using Microsoft Windows Server 2003 or 2008, you will be charged standard instance hour rates for Amazon EC2 running the appropriate Windows Server version, which includes the right to utilize that operating system within Amazon EC2. You are responsible for ensuring that all other installed software is properly licensed. So then, what happens to my on-premise Microsoft Windows license key when I import a VM of Windows Server 2003 or 2008? Since your on-premise Microsoft Windows license key that was associated with that VM is not used when running your imported VM as an EC2 instance, you can reuse it for another VM within your on-premise environment. Q. Can I continue to use the AWS provided Microsoft Windows license key after exporting an EC2 instance back to my on-premise virtualization environment? No. After an EC2 instance has been exported, the license key utilized in the EC2 instance is no longer available. You will need to reactivate and specify a new license key for the exported VM after it is launched in your on-premise virtualization platform. Q. When I import a VM with Red Hat Enterprise Linux, RHEL, who is responsible for supplying the operating system license? When you import Red Hat Enterprise Linux, RHEL VM images, you can use license portability for your role instances. With license portability, you are responsible for maintaining the role licenses for imported instances, which you can do using cloud access subscriptions for Red Hat Enterprise Linux. Please contact Red Hat to learn more about cloud access and to verify your eligibility. Q. How long does it take to import a virtual machine? The length of time to import a virtual machine depends on the size of the disk image and your network connection speed. As an example, a 10 GB Windows Server 2008 SP2 VMDK image takes approximately 2 hours to import when it's transferred over a 10 megabits per second network connection. If you have a slower network connection or a large disk to upload, your import may take significantly longer. Q. In which Amazon EC2 regions can I use VM import/export? Visit the region table page to see product service availability by region. Q. How many simultaneous import or export tasks can I have? Each account can have up to 5 active import tasks and 5 export tasks per region. Q. Can I run imported virtual machines in Amazon Virtual Private Cloud, VPC? Yes, you can launch imported virtual machines within Amazon VPC. Q. Can I use the AWS Management Console with VM import/export? No. VM import/export commands are available via EC2 CLI and API. You can also use the AWS Management Portal for vCenter to import VMs into Amazon EC2. Once imported, the resulting instances are available for use via the AWS Management Console. Billing and purchase options. Billing. Q. How will I be charged and billed for my use of Amazon EC2? You pay only for what you use. Displayed pricing is an hourly rate, but depending on which instances you choose, you pay by the hour or second, minimum of 60 seconds, for each instance type. Partial instance hours consumed are billed based on instance usage. Data transferred between AWS services in different regions is charged at standard inter-region data transfer rates. Usage for other Amazon Web Services is billed separately from Amazon EC2. For EC2 pricing information, please visit the pricing section on the EC2 detail page. Q. When does billing of my Amazon EC2 systems begin and end? Billing commences when Amazon EC2 initiates the boot sequence of an AMI instance. Billing ends when the instance terminates, which could occur through a web services command, by running shutdown H, or through instance failure. When you stop an instance, we shut it down but don't charge hourly usage for a stopped instance, or data transfer fees, but we do charge for the storage for any Amazon EBS volumes. To learn more, visit the AWS documentation. Q. What defines billable EC2 instance usage? Instance usages are billed for any time your instances are in a running state. If you no longer wish to be charged for your instance, you must stop or terminate the instance to avoid being billed for additional instance usage. Billing starts when an instance transitions into the running state. Q. If I have 2 instances in different availability zones, how will I be charged for regional data transfer? Each instance is charged for its data in and data out at corresponding data transfer rates. Therefore, if data is transferred between these 2 instances, it is charged at data transfer out from EC2 to another AWS region for the first instance, and at data transfer in from another AWS region for the second instance. Please refer to this page for detailed data transfer. Q. If I have 2 instances in different regions, how will I be charged for data transfer? Data transfer between 2 instances in AWS regions is charged at inter-region data transfer rates. Therefore, if data is transferred between these 2 instances, it is charged at Internet Data Transfer Out for the first instance and at Internet Data Transfer In for the second instance. Q. How will my monthly bill show per second versus per hour? Although EC2 charges in your monthly bill will now be calculated based on a per second basis, for consistency, the monthly EC2 bill will show cumulative usage for each instance that ran in a given month in decimal hours. An example would be an instance running for 1 hour 10 minutes and 4 seconds would look like 1.1677. Read this blog for an example of the detailed billing report. Q. Do your prices include taxes? Except as otherwise noted, our prices are exclusive of applicable taxes and duties, including VAT and applicable sales tax. For customers with a Japanese billing address, use of AWS services is subject to Japanese consumption tax. Learn more. Savings plans. What is savings plans? Savings plans is a flexible pricing model that offers low prices on EC2, Lambda and Fargate usage, in exchange for a commitment to a consistent amount of usage, measured in $/hour, for a 1 or 3 year term. When you sign up for savings plans, you will be charged the discounted savings plans price for your usage up to your commitment. For example, if you commit to $10 of compute usage an hour, you will get the savings plans prices on that usage up to $10, and any usage beyond the commitment will be charged on demand rates. What types of savings plans does AWS offer? AWS offers 2 types of savings plans. 1. Compute savings plans provides the most flexibility and help to reduce your costs by up to 66%. These plans automatically apply to EC2 instance usage regardless of instance family, size, OS, region, OS or tenancy, and also apply to AWS Fargate and Lambda usage. For example, with compute savings plans, you can change from C4 to M5 instances, shift a workload from EU, Ireland, to EU, London, or move a workload from EC2 to Fargate or Lambda at any time and automatically continue to pay the savings plan's price. 2. EC2 Instance Savings Plans provides the lowest prices, offering savings up to 72% in exchange for commitment to usage of individual instance families in a region, for example, M5 usage in Virginia. This automatically reduces your cost on the selected instance family in that region regardless of OS, size, OS or tenancy. EC2 Instance Savings Plans give you the flexibility to change your usage between instances within a family in that region. For example, you can move from C5.extra large running Windows to C5.2's large running Linux and automatically benefit from the savings plan prices. How do savings plans compare to EC2 REs? Savings plans offer significant savings over on demand, just like EC2 REs, but automatically reduce your bills on compute usage across any AWS region, even as usage changes. This provides you the flexibility to use the compute option that best suits your needs and continue to save money, all without having to perform exchanges or modifications. Compute savings plans, which provide savings up to 66%, just like convertible REs, automatically reduce your cost on any EC2 instance usage regardless of region, instance family, size, OS, tenancy, and even on AWS Fargate and Lambda. EC2 Instance Savings Plans, which provide savings up to 72%, just like standard REs, automatically save you money on any instance usage within a given EC2 instance family in a chosen region, for example, M5 in Virginia, regardless of size, OS or tenancy. Do savings plans provide capacity reservations for EC2 instances? No, savings plans do not provide a capacity reservation. You can, however, reserve capacity with on-demand capacity reservations and pay lower prices on them with savings plans. How do I get started with savings plans? You can get started with savings plans from AWS Cost Explorer in the Management Console or by using the API/CLI. You can easily make a commitment to a savings plan by using the recommendations provided in AWS Cost Explorer to realize the biggest savings. The recommended hourly commitment is based on your historical on-demand usage and your choice of plan type, term length, and payment option. Once you sign up for a savings plan, your compute usage will automatically be charged at the discounted savings plan prices, and any usage beyond your commitment will be charged at regular on-demand rates. Can I continue to purchase EC2 REs? Yes. You can continue purchasing REs to maintain compatibility with your existing cost management processes, and your REs will work alongside savings plans to reduce your overall bill. However, as your REs expire, we encourage you to sign up for savings plans as they offer the same savings as REs, but with additional flexibility. Convertible reserved instances. Q. What is a convertible RE? A convertible RE is a type of reserved instance with attributes that can be changed during the term. Q. When should I purchase a convertible RE instead of a standard RE? The convertible RE is useful for customers who can commit to using EC2 instances for a 3-year term in exchange for a significant discount on their EC2 usage, are uncertain about their instance needs in the future, or want to benefit from changes in price. Q. What term length options are available on convertible REs? Like standard REs, convertible REs are available for purchase for a 1-year or 3-year term. Q. Can I exchange my convertible RE to benefit from a convertible RE matching a different instance type, operating system, tenancy, or payment option? Yes, you can select a new instance type, operating system, tenancy, or payment option when you exchange your convertible REs. You also have the flexibility to exchange a portion of your convertible RE or merge the value of multiple convertible REs in a single exchange. Q. Can I transfer a convertible or standard RE from one region to another? No, a RE is associated with a specific region, which is fixed for the duration of the reservation's term. Q. How do I change the configuration of a convertible RE? You can change the configuration of your convertible RE using the EC2 Management Console or the Get Reserved Instances Exchanged API. You also have the flexibility to exchange a portion of your convertible RE or merge the value of multiple convertible REs in a single exchange. Click here to learn more about exchanging convertible REs. Q. Do I need to pay a fee when I exchange my convertible REs? No, you do not pay a fee when you exchange your REs. However, may need to pay a one-time true-up charge that accounts for differences in pricing between the convertible REs that you have and the convertible REs that you want. Q. How do convertible RE exchanges work? When you exchange one convertible RE for another, EC2 ensures that the total value of the convertible REs is maintained through a conversion. So, if you are converting your RE with a total value of $1,000 for another RE, you will receive a quantity of convertible REs with a value that's equal to or greater than $1,000. You cannot convert your convertible RE for convertible REs of a lesser total value. Q. Can you define total value? The total value is the sum of all expected payments that you'd make during the term for the RE. Q. Can you walk me through how the true-up cost is calculated for a conversion between two all-upfront convertible REs? Sure, let's say you purchased an all-upfront convertible RE for $1,000 upfront, and halfway through the term you decide to change the attributes of the RE. Since you're halfway through the RE term, you have $500 left of prorated value remaining on the RE. The all-upfront convertible RE that you want to convert into costs $1,200 upfront today. Since you only have half of the term left on your existing convertible RE, there is $600 of value remaining on the desired new convertible RE. The true-up charge that you'll pay will be the difference in upfront value between original and desired convertible REs, or $100, $600, $500. Q. Can you walk me through a conversion between no upfront convertible REs? Unlike conversions between convertible REs with an upfront value, since you're converting between REs without an upfront cost, there will not be a true-up charge. However, the amount you pay on an hourly basis before the exchange will need to be greater than or equal to the amount you pay on a total hourly basis after the exchange. For example, let's say you purchased one no upfront convertible RE A with a 10 cents per hour rate, and you decide to exchange convertible RE A for another RE B that costs 6 cents per hour. When you convert, you will receive two REs A B because the amount that you pay on an hourly basis must be greater than or equal to the amount you're paying for A on an hourly basis. Q. Can I customize the number of instances that I receive as a result of a convertible RE exchange? No, EC2 uses the value of the convertible REs you're trading in to calculate the minimal number of convertible REs you'll receive while ensuring the result of the exchange gives you convertible REs of equal or greater value. Q. Are there exchange limits for convertible REs? No, there are no exchange limits for convertible REs. Q. Do I have the freedom to choose any instance type when I exchange my convertible REs? No, you can only exchange into convertible REs that are currently offered by AWS. Q. Can I upgrade the payment option associated with my convertible RE? Yes, you can upgrade the payment option associated with your RE. For example, you can exchange your no upfront REs for partial or all upfront REs to benefit from better pricing. You cannot change the payment option from all upfront to no upfront, and cannot change from partial upfront to no upfront. Q. Do convertible REs allow me to benefit from price reductions when they happen? Yes, you can exchange your REs to benefit from lower pricing. For example, if the price of new convertible REs reduces by 10%, you can exchange your convertible REs and benefit from the 10% reduction in price. EC2 Fleet Q. What is Amazon EC2 Fleet? With a single API call, EC2 Fleet lets you provision compute capacity across different instance types, availability zones, and across on-demand, reserved instances, RE, and spot instances purchase models to help optimize scale, performance, and cost. Q. If I currently use Amazon EC2 Spot Fleet, should I migrate to Amazon EC2 Fleet? If you are leveraging Amazon EC2 Spot instances with Spot Fleet, you can continue to use that. Spot Fleet and EC2 Fleet offer the same functionality. There is no requirement to migrate. Q. Can I use reserved instance, RE, discounts with Amazon EC2 Fleet? Yes, similar to other EC2 APIs or other AWS services that launch as EC2 instances, if the on-demand instance launched by EC2 Fleet matches an existing RE, that instance will receive the RE discount. For example, if you own regional REs for M4 instances and you have specified only M4 instances in your EC2 Fleet, Rhode Island discounts will be automatically applied to this usage of M4. Q. Will Amazon EC2 Fleet fail ever to on-demand if EC2 Spot capacity is not fully fulfilled? No, EC2 Fleet will continue to attempt to meet your desired spot capacity based on the number of spot instances you requested in your fleet launch specification. Q. What is the pricing for Amazon EC2 Fleet? EC2 Fleet comes at no additional charge, you only pay for the underlying resources that EC2 Fleet launches. Q. Can you provide a real-world example of how I can use Amazon EC2 Fleet? There are a number of ways to take advantage of Amazon EC2 Fleet, such as in big data workloads, containerized application, grid processing workloads, etc. In this example of a genomic sequencing workload, you can launch a grid of worker nodes with a single API call, select your favorite instances, assign weights for these instances, specify target capacity for on-demand and spot instances, and build a fleet within seconds to crunch through genomic data quickly. Q. How can I allocate resources in an Amazon EC2 fleet? By default, EC2 Fleet will launch the on-demand option that is lowest price. For spot instances, EC2 Fleet provides 3 allocation strategies: capacity optimized, lowest price, and diversified. The capacity optimized allocation strategy attempts to provision spot instances from the most available spot instance pools by analyzing capacity metrics. This strategy is a good choice for workloads that have a higher cost of interruption, such as big data and analytics, image and media rendering, machine learning, and high-performance computing. The lowest price strategy allows you to provision spot instances in pools that provide the lowest price per unit of capacity at the time of the request. The diversified strategy allows you to provision spot instances across multiple spot pools, and you can maintain your fleet's target capacity to increase application. Q. Can I submit a multi-region Amazon EC2 fleet request? No, we do not support multi-region EC2 fleet requests. Q. Can I tag an Amazon EC2 fleet? Yes. You can tag a EC2 fleet request to create business-relevant tag groupings to organize resources along technical, business, and security dimensions. Q. Can I modify my Amazon EC2 fleet? Yes, you can modify the total target capacity of your EC2 fleet when in maintain mode. You may need to cancel the request and submit a new one to change other request configuration parameters. Q. Can I specify a different AMI for each instance type that I want to use? Yes, simply specify the AMI you'd like to use in each launch specification you provide in your EC2 fleet. On-demand capacity reservation. On-demand capacity reservation is an EC2 offering that lets you create and manage reserved capacity on Amazon EC2. You can create a capacity reservation by choosing an availability zone and quantity, number of instances, along with other instance specifications such as instance type and tenancy. Once created, the EC2 capacity is held for you regardless of whether you run the instances or not. Q. How much do capacity reservations cost? When the capacity reservation is active, you will pay equivalent instance charges whether you run the instances or not. If you do not use the reservation, the charge will show up as unused reservation on your EC2 bill. When you run an instance that matches the attributes of a reservation, you just pay for the instance and nothing for the reservation. There are no upfront or additional charges. For example, if you create a capacity reservation for 20 C5.2's large instances and you run 15 C5.2's large instances, you will be charged for 15 instances and 5 unused instances in the reservation, effectively charged for 20 instances. Q. Can I get a discount for capacity reservation usage? Yes. Savings plans or regional re-scope to a region, discounts apply to capacity reservations. AWS billing automatically applies your the discount when the attributes of a capacity reservation match the attributes of an active savings plan or a regional re. When a capacity reservation is used by an instance, you are only charged for the instance, with re-savings plan or re-discounts applied. Regional re-discounts are preferentially applied to running instance usages before covering unused capacity reservations. For example, if you have a regional re for 50 C5.2's large instances and a capacity reservation for 50 C5.2's large instances in the same region, the re-discount will apply to the unused portion of the reservation. Note that discounts will first apply to any C5 instance usage, across instances sizes and availability zones, within that region before applying to unused reservations. Note, a regional re is an EC2 re-scope to an AWS region. Zonal res, re-scope to an availability zone within a region. Discounts do not apply to on-demand capacity reservations, as zonal res already come with a capacity reservation. Q. When should I use savings plans, EC2 res, and capacity reservations? Use savings plans or regional res to reduce your bill while committing to a 1 or 3 year term. Savings plans offer significant savings over on-demand, just like EC2 res, but automatically reduce customers' bills on compute usage across any AWS region, even as usage changes. Use capacity reservations if you need the additional confidence in your ability to launch instances. Capacity reservations can be created for any duration and can be managed independently of your savings plans or res. If you have savings plans or regional res, they will automatically apply to matching capacity reservations. This gives you the flexibility to selectively add capacity reservations to a portion of your instance footprint and still reduce your bill for that usage.
Q. I have a zonal re-scoped to an availability zone, that also provides a capacity reservation?
How does this compare with a capacity reservation? A zonal RE provides both a discount and a capacity reservation in a specific availability zone in return for a 1 to 3 year commitment. Capacity reservation allows you to create and manage reserved capacity independently of your RE commitment and term length. You can use on-demand capacity reservations with a savings plan or a regional RE to get, at the minimum, all the benefits of a zonal RE for no additional cost. You also get the enhanced flexibility of savings plan, or regional RE, and the features of capacity reservation, the ability to add or subtract from the reservation at any time, view reservation utilization in real time, and the ability to target a capacity reservation for specific workloads. Rescoping your zonal REs to a region immediately gives you the availability zone and instance size flexibility in how RE discounts are applied. You can convert your standard zonal REs to a regional RE by modifying the scope of the RE from a specific availability zone to a region using the EC2 Management Console or the Modify Reserved Instances API.
Q. I created a capacity reservation.
How could I use it? A capacity reservation is tied to a specific availability zone and, by default, automatically utilized by running instances in that availability zone. When you launch new instances that match the reservation attributes, they will automatically match to the reservation. You can also target a reservation for specific workloads/instances if you prefer. Refer to Linux or Windows technical documentation to learn more about the targeting option. Q. How many instances am I allowed to reserve? The number of instances you are allowed to reserve is based on your account's on-demand instance limit. You can reserve as many instances as that limit allows, minus the number of instances that are already running. If you need a higher limit, contact your AWS sales representative or complete the Amazon EC2 instance request form with your use case and your instance increase will be considered. Limit increases are tied to the region they are requested for. Q. Can I modify a capacity reservation after it has started? Yes. You can reduce the number of instances you reserved at any time. You can also increase the number of instances, subject to availability. You can also modify the end time of your reservation. You cannot modify a capacity reservation that has ended or has been deleted. Q. Can I end a capacity reservation after it has started? Yes. You can end a capacity reservation by canceling it using the console or API/SDK, or by modifying your reservation to specify an end time that makes it expire automatically. Running instances are unaffected by changes to your capacity reservation, including deletion or expiration of a reservation. Q. Where can I find more information about using capacity reservations? Refer to Linux or Windows technical documentation to learn about creating and using a capacity reservation. Q. Can I share a capacity reservation with another AWS account? Yes, you can share capacity reservations with other AWS accounts or within your AWS organization via AWS Resource Access Manager service. You can share EC2 capacity reservations in 3 easy steps. Create a resource share using AWS Resource Access Manager, add resources. Capacity reservations to the resource share, and specify the target accounts that you wish to share the resources with. Note that sharing of capacity reservation is not available to new AWS accounts or AWS accounts that have a limited billing history. New accounts that are linked to a qualified master, payer, account or through an AWS organization are exempt from this restriction. Q. What happens when I share a capacity reservation with another AWS account? When a capacity reservation is shared with other accounts, those accounts can consume the reserved capacity to run their EC2 instances. The exact behavior depends by the preferences set on the capacity reservation. By default, capacity reservations automatically match existing and new instances from other accounts that have shared access to the reservation. You can also target a capacity reservation for specific workloads/instances. Individual accounts can control which of their instances consume capacity reservations. Refer to Linux or Windows technical documentation to learn more about the instance matching options. Q. Is there an additional charge for sharing a reservation? There is no additional charge for sharing a reservation. Q. Who gets charged when a capacity reservation is shared across multiple accounts? If multiple accounts are consuming a capacity reservation, each account gets charged for its own instance usage. Unused reserved capacity, if any, gets charged to the account that owns the capacity reservation. If there's a consolidated billing arrangement among the accounts that share a capacity reservation, the master account gets billed for instance usage across all the linked accounts. Q. Can I prioritize access to capacity reservation among the AWS accounts that have shared access? No. Instance spots in a capacity reservation are available on a first-come first-served basis to any account that has shared access. Q. How can I communicate the availability zone, AWS, of a CR with another account, given AWS name mappings could be different across AWS accounts. You can now use Availability Zone ID as ID instead of AWS name. Availability Zone ID is a static reference and provides a consistent way of identifying the location of a resource across all your accounts. This makes it easier for you to provision resources centrally in a single account and share them across multiple accounts. Q. Can I stop sharing my capacity reservation once I have shared it? Yes, you can stop sharing a reservation after you have shared it. When you stop sharing a CR with specific accounts or stop sharing entirely, other accounts lose the ability to launch new instances into the CR. Any capacity occupied by instances running from other accounts will be restored to the CR for your use, subject to availability. Q. Where can I find more information about sharing capacity reservations? Refer to Linux or Windows technical documentation to learn about sharing capacity reservations. Q. Can I get a discount for capacity reservation usage? Yes. Savings plans or regional RE discounts apply to capacity reservations. AWS billing automatically applies the discount when the attributes of a capacity reservation match the attributes of a savings plan or a regional RE. When a capacity reservation is used by an instance, you are only charged for the instance, with savings plan or RE discounts applied. Discounts are preferentially applied to instance usage before covering unused capacity reservations. Note, a regional RE is an EC2 RE scope to an AWS region. Zonal RE scope to an availability zone within a region. Discounts do not apply to on-demand capacity reservations, as zonal REs already come with a capacity reservation. Reserved instances. Q. What is a reserved instance? A reserved instance RE is an EC2 offering that provides you with a significant discount on EC2 usage when you commit to a 1-year or 3-year term. Q. What are the differences between standard REs and convertible REs? Standard REs offer a significant discount on EC2 instance usage when you commit to a particular instance family. Convertible REs offer you the option to change your instance configuration during the term, and still receive a discount on your EC2 usage. For more information on convertible REs, please click here. Q. Do REs provide a capacity reservation? Yes, when a standard or convertible RE is scoped to a specific availability zone, AWS, instance capacity matching the exact RE configuration is reserved for your use. These are referred to as zonal REs. Zonal REs give you additional confidence in your ability to launch instances when you need them. You can also choose to forego the capacity reservation and purchase standard or convertible REs that are scoped to a region, referred to as regional REs. Regional REs automatically apply the discount to usage across availability zones and instance sizes in a region, making it easier for you to take advantage of the RE's discounted rate. Q. When should I purchase a zonal RE? If you want to take advantage of the capacity reservation, then you should buy an RE in a specific availability zone. Q. When should I purchase a regional RE? If you do not require the capacity reservation, then you should buy a regional RE. Regional REs provide AWS and instance size flexibility, which offers broader applicability of the RE's discounted rate. Q. What are availability zone and instance size flexibility? Availability zone and instance size flexibility make it easier for you to take advantage of your regional RE's discounted rate. Availability zone flexibility applies your RE's discounted rate to usage in any availability zone in a region, while instance size flexibility applies your RE's discounted rate to usage of any size within an instance family. Let's say you own an M5.2's large Linux/Unix regional RE with default tenancy in US East and Virginia. Then this RE's discounted rate can automatically apply to 2 M5.extra large instances in US East 1A or 4 M5. Large instances in US East 1B. Q. What types of REs provide instance size flexibility? Linux/Unix regional REs with the default tenancy provide instance size flexibility. Instance size flexibility is not available on REs of other platforms such as Windows, Windows with SQL Standard, Windows with SQL Server Enterprise, Windows with SQL Server Web, ROL, and SOLS or G4 instances. Q. Do I need to take any action to take advantage of availability zone and instance size flexibility? Regional REs do not require any action to take advantage of availability zone and instance size flexibility. Q. I own zonal REs. How do I assign them to a region? You can assign your standard zonal REs to a region by modifying the scope of the RE from a specific availability zone to a region from the EC2 Management Console or by using the Modify Reserved Instances API. Q. How do I purchase an RE? To get started, you can purchase an RE from the EC2 Management Console or by using the AWS CLI. Simply specify the instance type, platform, tenancy, term, payment option, and region or availability zone. Q. Can I purchase NRE for a running instance? Yes, AWS will automatically apply NRE's discounted rate to any applicable instance usage from the time of purchase. Visit the Getting Started page to learn more. Q. Can I control which instances are billed at the discounted rate? No. AWS automatically optimizes which instances are charged at the discounted rate to ensure you always pay the lowest amount. For information about billing, and how it applies to REs, see billing benefits and payment options. Q. How does instance size flexibility work? EC2 uses the scale shown below to compare different sizes within an instance family. In the case of instance size flexibility on REs, this scale is used to apply the discounted rate of REs to the normalized usage of the instance family. For example, if you have an M5.2's large RE that is scoped to a region, then your discounted rate could apply towards the usage of one M5.2's large or two M5.extra large instances. Click here to learn more about how instance size flexibility of REs applies to your EC2 usage. And click here to learn about how instance size flexibility of REs is presented in the cost and usage report. Q. Can I change my RE during its term? Yes, you can modify the availability zone of the RE, change the scope of the RE from availability zone to region, and vice versa, change the network platform from EC2 VPC to EC2 Classic, and vice versa, or modify instance sizes within the same instance family, on the Linux/Unix platform. Q. Can I change the instance type of my RE during its term? Yes, convertible REs offer you the option to change the instance type, operating system, tenancy or payment option of your RE during its term. Please refer to the convertible RE section of the FAQ for additional information. Q. What are the different payment options for REs? You can choose from 3 payment options when you purchase an RE. With the all upfront option, you pay for the entire RE term with one upfront payment. With a partial upfront option, you make a low upfront payment, and are then charged a discounted hourly rate for the instance for the duration of the RE term. The no upfront option does not require any upfront payment and provides a discounted hourly rate for the duration of the term. Q. When are REs activated? The billing discount and capacity reservation, if applicable, is activated once your payment has successfully been authorized. You can view the status, pending, active, retired, of your REs on the reserved instances page of the Amazon EC2 console. Q. Do REs apply to spot instances or instances running on a dedicated host? No, REs do not apply to spot instances or instances running on dedicated hosts. To lower the cost of using dedicated hosts, purchase dedicated host reservations. Q. How do REs work with consolidated billing? Our system automatically optimizes which instances are charged at the discounted rate to ensure that the consolidated accounts always pay the lowest amount. If you own REs that apply to an availability zone, then only the account which owns the RE will receive the capacity reservation. However, the discount will automatically apply to usage in any account across your consolidated billing family. Q. Can I get a discount on RE purchases? Yes, EC2 provides tiered discounts on RE purchases. These discounts are determined based on the total list value, non-discounted price, for the active REs you have per region. Your total list value is the sum of all expected payments for an RE within the term, including both the upfront and recurring hourly payments. The tier ranges and corresponding discounts are shown alongside. $4M, $10M, 10% more than $10 million call us 10% Q. Can you help me understand how volume discounts are applied to my RE purchases? Sure. Let's assume that you currently have $400,000 worth of active REs in the US East 1 region. Now, if you purchase REs worth $150,000 in the same region, then the first $100,000 of this purchase would not receive a discount. However, the remaining $50,000 of this purchase would be discounted by 5%, so you would only be charged $47,500 for this portion of the purchase over the term based on your payment option. To learn more, please visit the Understanding Reserved Instance Discount Pricing tier portion of the Amazon EC2 user guide. Q. How do I calculate the list value of an RE? Here is a sample list value calculation for 3-year partial upfront reserved instances. Q. How are volume discounts calculated if I use consolidated billing? If you leverage consolidated billing, AWS will use the aggregate total list price of active REs across all of your consolidated accounts to determine which volume discount tier to apply. Volume discount tiers are determined at the time of purchase, so you should activate consolidated billing prior to purchasing REs to ensure that you benefit from the largest possible volume discount that your consolidated accounts are eligible to receive. Q. Do convertible REIs qualify for volume discounts? No, however, the value of each convertible RE that you purchase contributes to your volume discount tier standing. Q. How do I determine which volume discount tier applies to me? To determine your current volume discount tier, please consult the Understanding Reserved Instance Discount Pricing Tiers portion of the Amazon EC2 User Guide. Q. Will the cost of my REIs change if my future volume qualifies me for other discount tiers? No. Volume discounts are determined at the time of purchase, therefore the cost of your REIs will continue to remain the same as you qualify for other discount tiers. Any new purchase will be discounted according to your eligible volume discount tier at the time of purchase. Q. Do I need to take any action at the time of purchase to receive volume discounts? No, you will automatically receive volume discounts when you use the existing Purchase Reserved Instance API or EC2 Management Console interface to purchase REIs. If you purchase more than $10 million worth of REIs, contact us about receiving discounts beyond those that are automatically provided. Reserved Instance Marketplace. Q. What is the Reserved Instance Marketplace? The Reserved Instance Marketplace is an online marketplace that provides AWS customers the flexibility to sell their Amazon Elastic Compute Cloud, Amazon EC2, reserved instances to other businesses and organizations. Customers can also browse the Reserved Instance Marketplace to find an even wider selection of reserved instance term lengths and pricing options sold by other AWS customers. Q. When can I list a reserved instance on the Reserved Instance Marketplace? You can list a reserved instance when you've registered as a seller in the Reserved Instance Marketplace. You've paid for your reserved instance. You've owned the reserved instance for longer than 30 days. Q. How will I register as a seller for the Reserved Instance Marketplace? To register for the Reserved Instance Marketplace, you can enter the registration workflow by selling a reserved instance from the EC2 Management Console or setting up your profile from the Account Settings page on the AWS portal. No matter the route, you will need to complete the following steps. 1. Start by reviewing the overview of the registration process. 2. Log into your AWS account. 3. Enter in the bank account into which you want us to disperse funds. Once you select Continue, we will set that bank account as the default disbursement option. 4. In the confirmation screen, choose Continue to Console to start listing. If you exceed $20,000 in sales of reserved instances, or plan to sell 50 or more reserved instances, you will need to provide tax information before you can list your reserved instances. Choose Continue with Tax Interview. During the tax interview pipeline, you will be prompted to enter your company name, contact name, address and tax identification number using the TIMS workflow. Additionally, if you plan to sell reserved instances worth more than $50,000 per year, you will also need to file a limit increase. Q. How will I know when I can start selling on the Reserved Instance Marketplace? You can start selling on the Reserved Instance Marketplace after you have added a bank account through the registration pipeline. Once activation is complete, you will receive a confirmation email. However, it is important to note that you will not be able to receive disbursements until we are able to receive verification from your bank, which may take up to 2 weeks, depending on the bank you use. Q. How do I list a reserved instance for sale? To list a reserved instance, simply complete these steps in the Amazon EC2 console. 1. Select the reserved instances you wish to sell, and choose Sell Reserved Instances. If you have not completed the registration process, you will be prompted to register using the registration pipeline. 2. For each reserved instance type, set the number of instances you'd like to sell, and the price for the one-time fee you would like to set. Note that you can set the one-time price to different amounts depending on the amount of time remaining so that you don't have to keep adjusting your one-time price if your reserved instance doesn't sell quickly. By default, you just need to set the current price and we will automatically decrease the one-time price by the same increment each month. 3. Once you have configured your listing, a final confirmation screen will appear. Choose Sell Reserved Instance. Q. Which reserved instances can I list for sale? You can list any reserved instances that have been active for at least 30 days, and for which we have received payment. Typically, this means that you can list your reservations once they are in the active state. It is important to note that if you are an invoice customer, your reserved instance can be in the active state prior to AWS receiving payment. In this case, your reserved instance will not be listed until we have received your payment. Q. How are listed reserved instances displayed to buyers? Reserved instances, both third-party and those offered by AWS, that have been listed on the Reserved Instance Marketplace can be viewed in the Reserved Instances section of the Amazon EC2 console. You can also use the Describe Reserved Instances Listings API call. The listed reserved instances are grouped based on the type, term remaining, upfront price, and hourly price. This makes it easier for buyers to find the right reserved instances to purchase. Q. How much of my reserved instance term can I list? You can sell a reserved instance for the term remaining, rounded down to the nearest month. For example, if you had 9 months and 13 days remaining, you will list it for sale as a 9-month term reserved instance. Q. Can I remove my reserved instance after I've listed it for sale? Yes, you can remove your reserved instance listings at any point until a sale is pending, meaning a buyer has bought your reserved instance and confirmation of payment is pending. Q. Which pricing dimensions can I set for the reserved instances I want to list? Using the reserved instance marketplace, you can set an upfront price you'd be willing to accept. You cannot set the hourly price, which will remain the same as was set on the original reserved instance, and you will not receive any funds collected from payments associated with the hourly prices. Q. Can I still use my reservation while it is listed on the reserved instance marketplace? Yes, you will continue to receive the capacity and billing benefit of your reservation until it is sold. Once sold, any running instance that was being charged at the discounted rate will be charged at the on-demand rate until and unless you purchase a new reservation, or terminate the instance. Q. Can I resell a reserved instance that I purchased from the reserved instance marketplace? Yes, you can resell reserved instances purchased from the reserved instance marketplace just like any other reserved instance. Q. Are there any restrictions when selling reserved instances? Yes, you must have a U.S. bank account to sell reserved instances in the reserved instance marketplace. Support for non-U.S. bank accounts will be coming soon. Also, you may not sell reserved instances in the U.S. GovCloud region. Q. Can I sell reserved instances purchased from the public volume pricing tiers? No, this capability is not yet available. Q. Is there a charge for selling reserved instances on the reserved instance marketplace? Yes, AWS charges a service fee of 12% of the total upfront price of each reserved instance you sell in the reserved instance marketplace. Q. Can AWS sell subsets of my listed reserved instances? Yes, AWS may potentially sell a subset of the quantity of reserved instances that you have listed. For example, if you list 100 reserved instances, we may only have a buyer interested in purchasing 50 of them. We will sell those 50 instances and continue to list your remaining 50 reserved instances until and unless you decide not to list them any longer. Q. How do buyers pay for reserved instances that they've purchased? Payment for completed reserved instance sales are done via ACH wire transfers to a U.S. bank account. Q. When will I receive my money? Once AWS has received funds from the customer that has bought your reservation, we will disperse funds via wire transfer to the bank account you specified when you registered for the reserved instance marketplace. Then, we will send you an email notification letting you know that we've wired you the funds. Typically, funds will appear in your account within 3 to 5 days of when your reserved instance was been sold. Q. If I sell my reserved instance in the reserved instance marketplace, will I get refunded for the premium support I was charged to? No, you will not receive a prorated refund for the upfront portion of the AWS premium support fee. Q. Will I be notified about reserved instance marketplace activities? Yes, you will receive a single email once a day that details your reserved instance marketplace activity whenever you create or cancel reserved instance listings, buyers purchase your listings, or AWS disperses funds to your bank account. Q. What information is exchanged between the buyer and seller to help with the transaction tax calculation? The buyer's city, state, zip +4, and country information will be provided to the seller via a disbursement report. This information will enable sellers to calculate any necessary transaction taxes they need to remit to the government, for example, sales tax, value-added tax, etc. The legal entity name of the seller will also be provided on the purchase invoice. Q. Are there any restrictions on the customers when purchasing third-party reserved instances? Yes, you cannot purchase your own listed reserved instances, including those in any of your linked accounts, via consolidated billing. Q. Do I have to pay for premium support when purchasing reserved instances from the reserved instance marketplace? Yes, if you are a premium support customer, you will be charged for premium support when you purchase a reserved instance through the reserved instance marketplace. Spot instances. Q. What is a spot instance? Spot instances are spare EC2 capacity that can save you up 90% off of on-demand prices that AWS can interrupt with a 2-minute notification. Spot uses the same underlying EC2 instances as on-demand and reserved instances, and is best suited for fault-tolerant, flexible workloads. Spot instances provides an additional option for obtaining compute capacity and can be used along with on-demand and reserved instances. Q. How is a spot instance different than an on-demand instance or reserved instance? While running, spot instances are exactly the same as on-demand or reserved instances. The main differences are that spot instances typically offer a significant discount off the on-demand prices. Your instances can be interrupted by Amazon EC2 for capacity requirements with a 2-minute notification, and spot prices adjust gradually based on long-term supply and demand for spare EC2 capacity. See here for more details on spot instances. Q. How do I purchase and start up a spot instance? Spot instances can be launched using the same tools you use launch instances today, including AWS Management Console, auto-scaling groups, run instances, and Spot Fleet. In addition, many AWS services support launching spot instances such as EMR, ECS, Data Pipeline, CloudFormation, and Batch. To start up a spot instance, you simply need to choose a launch template and the number of instances you would like to request. See here for more details on how to request spot instances. Q. How many spot instances can I request? You can request spot instances up to your spot limit for each region. Note that customers new to AWS might start with a lower limit. To learn more about spot instance limits, please refer to the Amazon EC2 user guide. If you would like a higher limit, complete the Amazon EC2 instance request form with your use case and your instance increase will be considered. Limit increases are tied to the region they were requested for. Q. What price will I pay for a spot instance? You pay the spot price that's in effect at the beginning of each instance hour for your running instance. If spot price changes after you launch the instance, the new price is charged against the instance usage for the subsequent hour. Q. What is a spot capacity pool? A spot capacity pool is a set of unused EC2 instances with the same instance type, operating system, availability zone, and network platform, EC2 Classic or EC2 VPC. Each spot capacity pool can have a different price based on supply and demand. Q. What are the best practices to use spot instances? We highly recommend using multiple spot capacity pools to maximize the amount of spot capacity available to you. EC2 provides built-in automation to find the most cost-effective capacity across multiple spot capacity pools using EC2 auto-scaling, EC2 Fleet or Spot Fleet. For more information, please see Spot Best Practices. Q. How can I determine the status of my spot request? You can determine the status of your spot request via spot request status code and message. You can access spot request status information on the spot instance page of the EC2 console of the AWS Management Console, API and CLI. For more information, please visit the Amazon EC2 Developer Guide. Q. Are spot instances available for all instance families and sizes and in all regions? Spot instances are available in all public AWS regions. Spot is available for nearly all EC2 instance families and sizes, including the newest compute-optimized instances, accelerated graphics, and FPGA instance types. A full list of instance types supported in each region are listed here. Q. Which operating systems are available as spot instances? Linux/Unix, Windows Server and Red Hat Enterprise Linux, RHEL, are available. Windows Server with SQL Server is not currently available. Q. Can I use a spot instance with a paid AMI for third-party software, such as IBM software packages? Not at this time. Q. Can I stop my running spot instances? Yes, you can stop your running spot instances when they are not needed and keep these stopped instances for later use, instead of terminating instances or canceling the spot request. Stop is available for persistent spot requests. Q. How can I stop the spot instances? You can stop your spot instances by calling the Stop Instances API and providing instance IDs of the spot instances similar to stopping your on-demand instances. You can also do this through the AWS Management Console by selecting your instance, then clicking actions greater than instance state greater than stop. Q. How can I start the stop spot instances? You can start the stop spot instances by calling the Start Instances API and providing instance IDs of the spot instances similar to starting your on-demand instances. You can also do this through the AWS Management Console by selecting your instance, then clicking actions greater than instance state greater than start. Note, the spot instances will start only if spot capacity is still available within your maximum price. Spot evaluates capacity availability every time whenever you will start the stop spot instances. Q. How can I tell whether I have stopped my spot instance or it has been interrupted? You can tell that the spot instance has been stopped by you or interrupted by looking at the spot request status code. This is visible as Spot Request status on the Spot Requests page of the AWS Management Console or in the described Spot Instance Requests API Responses status code field. If the Spot Request status code is instance stopped by user, it means that you have stopped your Spot instance. Q. How will I be charged if my Spot instance is stopped or interrupted? If your Spot instance is terminated or stopped by Amazon EC2 in the first instance hour, you will not be charged for that usage. However, if you stop or terminate the Spot instance yourself, you will be charged to the nearest second. If the Spot instance is terminated or stopped by Amazon EC2 in any subsequent hour, you will be charged for your usage to the nearest second. If you are running on Windows or Red Hat Enterprise Linux, RHEL, and you stop or terminate the Spot instance yourself, you will be charged for an entire hour. Q. When would my Spot instance get interrupted? Over the last 3 months, 92% of Spot instance interruptions were from a customer manually terminating the instance because the application had completed its work. In the circumstance EC2 needs to reclaim your Spot instance, it can be for 2 possible reasons, with the primary one being Amazon EC2 capacity requirements, for example, on-demand or reserved instance usage. Secondarily, if you have chosen to set a maximum spot price and the spot price rises above this, your instance will be reclaimed with a 2-minute notification. This parameter determines the maximum price you would be willing to pay for a Spot instance hour, and by default, is set at the on-demand price. As before, you continue to pay the spot market price, not your maximum price, at the time your instance was running, charged in per second increments. Q. What happens to my Spot instance when it gets interrupted? You can choose to have your Spot instances terminated, stopped or hibernated upon interruption. Stop and hibernate options are available for persistent Spot requests and Spot fleets with the maintain option enabled. By default, your instances are terminated. Refer to Spot hibernation to learn more about handling interruptions. Q. What is the difference between stop and hibernate interruption behaviors? In the case of hibernate, your instance gets hibernated and the RAM data persisted. In the case of stop, your instance gets shut down and RAM is cleared. In both the cases, data from your EBS root volume and any attached EBS data volumes is persisted. Your private IP address remains the same, as does your elastic IP address, if applicable. The network layer behavior will be similar to that of EC2 stop-start workflow. Stop and hibernate are available for Amazon EBS-backed instances only. Local instance storage is not persisted. Q. What if my EBS root volume is not large enough to store memory state, RAM, for hibernate? You should have sufficient space available on your EBS root volume to write data from memory. If the EBS root volume does not enough space, hibernation will fail and the instance will get shut down instead. Ensure that your EBS volume is large enough to persist memory data before choosing the hibernate option. Q. What is the benefit if Spot hibernates my instance on interruption? With hibernate, Spot instances will pause and resume around any interruption so your workloads can pick up from exactly where they left off. You can use hibernation when your instances need to retain instance state across shutdown startup cycles, i.e. when your applications running on Spot depend on contextual, business, or session data stored in RAM. Q. What do I need to do to enable hibernation for my Spot instances? Refer to Spot hibernation to learn about enabling hibernation for your Spot instances. Q. Do I have to pay for hibernating my Spot instance? There is no additional charge for hibernating your instance beyond the EBS storage costs and any other EC2 resources you may be using. You are not charged instance usage fees once your instance is hibernated. Q. Can I resume a hibernated instance? No, you will not be able to resume a hibernated instance directly. Hibernate resume cycle is controlled by Amazon EC2. If an instance is hibernated by Spot, it will be resumed by Amazon EC2 when the capacity becomes available. Q. Which instances and operating systems support hibernation? Spot hibernation is currently supported for Amazon Linux AMIs, Ubuntu and Microsoft Windows operating systems running on any instance type across C3, C4, C5, M4, M5, R3, R4 instances with memory, RAM, size less than 100 GB. To review the list of supported OS versions, refer to Spot hibernation. Q. How am I charged if Spot price changes while my instance is running? You will pay the price per instance hour set at the beginning of each instance hour for the entire hour, billed to the nearest second. Q. Where can I see my usage history for Spot instances and see how much I was billed? The AWS Management Console makes a detailed billing report available which shows Spot instance start and termination/stop times for all instances. Customers can check the billing report against historical spot prices via the API to verify that the spot price they were billed is correct. Q. Are spot blocks, fixed duration spot instances, ever interrupted? Spot blocks are designed not to be interrupted, and will run continuously for the duration you select, independent of spot market price. In rare situations, spot blocks may be interrupted due to AWS capacity needs. In these cases, we will provide a 2-minute warning before we terminate your instance, termination notice, and you will not be charged for the affected instances. Q. What is a spot fleet? A spot fleet allows you to automatically request and manage multiple spot instances that provide the lowest price per unit of capacity for your cluster or application, like a batch processing job, a Hadoop workflow, or an HPC grid computing job. You can include the instance types that your application can use. You define a target capacity based on your application needs, in units including instances, FAQs, memory, storage, or network throughput, and update the target capacity after the fleet is launched. Spot fleets enable you to launch and maintain the target capacity, and to automatically request resources to replace any that are disrupted or manually terminated. Learn more about spot fleets. Q. Is there any additional charge for making spot fleet requests? No, there is no additional charge for spot fleet requests. Q. What limits apply to a spot fleet request? Visit the Spot Fleet Limits section of the Amazon EC2 user guide to learn about the limits that apply to your spot fleet request. Q. What happens if my spot fleet request tries to launch spot instances but exceeds my regional spot request limit? If your spot fleet request exceeds your regional spot instance request limit, individual spot instance requests will fail with a spot request limit exceeded request status. Your spot fleet requests history will show any spot request limit errors that the fleet request received. Visit the Monitoring Your Spot Fleet section of the Amazon EC2 user guide to learn how to describe your spot fleet requests history. Q. Are spot fleet requests guaranteed to be fulfilled? No. Spot fleet requests allow you to place multiple spot instance requests simultaneously, and are subject to the same availability and prices as a single spot instance request. For example, if no resources are available for the instance types listed in your spot fleet request, we may be unable to fulfill your request partially or in full. We recommend you to include all the possible instance types and availability zones that are suitable for your workloads in the spot fleet. Q. Can I submit a multi-availability zone spot fleet request? Yes, visit the Spot Fleet Examples section of the Amazon EC2 user guide to learn how to submit a multi-availability zone spot fleet request. Q. Can I submit a multi-region spot fleet request? No, we do not support multi-region fleet requests. Q. How does Spot Fleet allocate resources across the various spot instance pools specified in the launch specifications? The Request Spot Fleet API provides 3 allocation strategies: capacity optimized, lowest price, and diversified. The capacity optimized allocation strategy attempts to provision spot instances from the most available spot instance pools by analyzing capacity metrics. This strategy is a good choice for workloads that have a higher cost of interruption, such as big data and analytics, image and media rendering, machine learning, and high-performance computing. The lowest price strategy allows you to provision your spot fleet resources in instance pools that provide the lowest price per unit of capacity at the time of the request. The diversified strategy allows you to provision your spot fleet resources across multiple spot instance pools. This enables you to maintain your fleet's target capacity and increase your application's availability as spot capacity fluctuates. Running your application's resources across diverse spot instance pools also allows you to further reduce your fleet's operating costs over time. Visit the Amazon EC2 user guide to learn more. Q. Can I tag a spot fleet request? You can request to launch spot instances with tags via Spot Fleet. The fleet by itself cannot be tagged. Q. How can I see which spot fleet owns my spot instances? You can identify the spot instances associated with your spot fleet by describing your fleet request. Fleet requests are available for 48 hours after all its spot instances have been terminated. See the Amazon EC2 user guide to learn how to describe your spot fleet request. Q. Can I modify my spot fleet request? Yes, you can modify the target capacity of your spot fleet request. You may need to cancel the request and submit a new one to change other request configuration parameters. Q. Can I specify a different AMI for each instance type that I want to use? Yes, simply specify the AMI you'd like to use in each launch specification you provide in your spot fleet request. Q. Can I use spot fleet with elastic load balancing, auto-scaling, or elastic MapReduce? You can use auto-scaling features with spot fleet such as target tracking, health checks, CloudWatch metrics, etc., and can attach instances to your Elastic load balancers, both classic and application load balancers. Elastic MapReduce has a feature named Instance Fleets that provides capabilities similar to Spot Fleet. Q. Does a Spot Fleet request terminate Spot instances when they are no longer running in the lowest priced or capacity optimized Spot pools and relaunch them? No, Spot Fleet requests do not automatically terminate and relaunch instances while they are running. However, if you terminate a Spot instance, Spot Fleet will replenish it with a new Spot instance in the new lowest priced pool or capacity optimized pool based on your allocation strategy. Q. Can I use stop or hibernation interruption behaviors with Spot Fleet? Yes, stop, start, and hibernate resume are supported with Spot Fleet with maintain fleet option enabled. Platform Amazon Time Sync Service Q. How do I use this service? The service provides an NTP endpoint at a linked local IP address, 169.254.169.123, accessible from any instance running in a VPC. Instructions for configuring NTP clients are available for Linux and Windows. Q. What are the key benefits of using this service? A consistent and accurate reference time source is crucial for many applications and services. The Amazon Time Sync service provides a time reference that can be securely accessed from an instance without requiring VPC configuration changes and updates. It is built on Amazon's proven network infrastructure and uses redundant reference time sources to ensure high accuracy and availability. Q. Which instance types are supported for this service? All instances running in a VPC can access the service. Availability zones. Q. How isolated are availability zones from one another? Each availability zone runs on its own physically distinct, independent infrastructure, and is engineered to be highly reliable. Common points of failures like generators and cooling equipment are not shared across availability zones. Additionally, they are physically separate, such that even extremely uncommon disasters such as fires, tornadoes, or flooding would only affect a single availability zone. Q. Is Amazon EC2 running in more than one region? Yes. Please refer to regional products and services for more details of our product and service availability by region. Q. How can I make sure that I am in the same availability zone as another developer? We do not currently support the ability to coordinate launches into the same availability zone across AWS developer accounts. One availability zone name, for example, US East 1A, in two AWS customer accounts may relate to different physical availability zones. Q. If I transfer data between availability zones using public IP addresses, will I be charged twice for regional data transfer, once because it's across zones, and a second time because I'm using public IP addresses? No. Regional data transfer rates apply if at least one of the following is true, but is only charged once for a given instance even if both are true. The other instance is in a different availability zone, regardless of which type of address is used. Public or elastic IP addresses are used, regardless of which availability zone the other instance is in. Cluster instances. Q. What is a cluster compute instance? Cluster compute instances combine high compute resources with a high-performance networking for high-performance compute, HPC, applications and other demanding network-bound applications. Cluster compute instances provide similar functionality to other Amazon EC2 instances but have been specifically engineered to provide high-performance networking. Amazon EC2 Cluster Placement Group functionality allows users to group cluster compute instances in clusters, allowing applications to get the low latency network performance necessary for tightly coupled node-to-node communication typical of many HPC applications. Cluster compute instances also provide significantly increased network throughput both within the Amazon EC2 environment and to the Internet. As a result, these instances are also well suited for customer applications that need to perform network-intensive operations. Learn more about use of this instance type for HPC applications. Q. What kind of network performance can I expect when I launch instances in Cluster Placement Group? The bandwidth an EC2 instance can utilize in a cluster placement group depends on the instance type and its networking performance specification. Inter-instance traffic within the same region can utilize 5 gigabits per second for single flow and up to 25 gigabits per second for multi-flow traffic. When launched in a placement group, select EC2 instances can utilize up to 10 gigabits per second for single flow traffic. Q. What is a cluster GPU instance? Cluster GPU instances provide general-purpose graphics processing units (GPUs) with proportionally high CPU and increased network performance for applications benefiting from highly parallelized processing that can be accelerated by GPUs using the CUDA and OpenCL programming models. Common applications include modeling and simulation, rendering and media processing. Cluster GPU instances give customers with HPC workloads an option beyond cluster compute instances to further customize their high-performance clusters in the cloud for applications that can benefit from the parallel computing power of GPUs. Cluster GPU instances use the same cluster placement group functionality as cluster compute instances for grouping instances into clusters, allowing applications to get the low latency, high bandwidth network performance required for tightly coupled node-to-node communication typical of many HPC applications. Learn more about HPC on AWS. Q. What is a high memory cluster instance? High memory cluster instances provide customers with large amounts of memory and CPU capabilities per instance in addition to high network capabilities. These instance types are ideal for memory-intensive workloads including in memory analytics systems, graph analysis and any science and engineering applications. High memory cluster instances use the same cluster placement group functionality as cluster compute instances for grouping instances into clusters, allowing applications to get the low latency, high bandwidth network performance required for tightly coupled node-to-node communication typical of many HPC and other network-intensive applications. Q. Does use of cluster compute and cluster GPU instances differ from other Amazon EC2 instance types? Cluster compute and cluster GPU instances use differs from other Amazon EC2 instance types in two ways. First, cluster compute and cluster GPU instances use hardware virtual machine, HVM, based virtualization and on only Amazon machine images, AMIs, based on HVM virtualization. Paravirtual machine, PVM, based AMIs used with other Amazon EC2 instance types cannot be used with cluster compute or cluster GPU instances. Second, in order to fully benefit from the available low latency, full bisection bandwidth between instances, cluster compute and cluster GPU instances must be launched into a cluster placement group through the Amazon EC2 API or AWS Management Console. Q. What is a cluster placement group? A cluster placement group is a logical entity that enables creating a cluster of instances by launching instances as part of a group. The cluster of instances then provides low latency connectivity between instances in the group. Cluster placement groups are created through the Amazon EC2 API or AWS Management Console. Q. Are all features of Amazon EC2 available for cluster compute and cluster GPU instances? Currently, Amazon DevPay is not available for cluster compute or cluster GPU instances. Q. Is there a limit on the number of cluster compute or cluster GPU instances I can use and or the size of cluster I can create by launching cluster compute instances or cluster GPU into a cluster placement group? There is no limit specific for cluster compute instances. For cluster GPU instances, you can launch 2 instances on your own. If you need more capacity, please complete the Amazon EC2 instance request form, selecting the appropriate primary instance type. Q. Are there any ways to optimize the likelihood that I receive the full number of instances I request for my cluster via a cluster placement group? We recommend that you launch the minimum number of instances required to participate in a cluster in a single launch. For very large clusters, you should launch multiple placement groups, for example, 2 placement groups of 128 instances and combine them to create a larger, 256 instance cluster. Q. Can cluster GPU and cluster compute instances be launched into a single cluster placement group? While it may be possible to launch different cluster instance types into a single placement group, at this time we only support homogeneous placement groups. Q. If an instance in a cluster placement group is stopped then started again, will it maintain its presence in the cluster placement group? Yes. A stopped instance will be started as part of the cluster placement group it was in when it stopped. If capacity is not available for it to start within its cluster placement group, the start will fail. Hardware information. Q. What CPU options are available on EC2 instances? EC2 instances offer a variety of CPU options to help customers balance performance and cost requirements. Depending on the instance type, EC2 offers a choice in CPU including AWS Graviton/Graviton2 processors, ARM, AMD processors, x86, and Intel processors, x86. Q. What kind of hardware will my application stack run on? Visit Amazon EC2 instance type for a list of EC2 instances available by region. Q. How does EC2 perform maintenance? AWS regularly performs routine hardware, power and network maintenance without disrupting customer instances. To achieve this, we employ a combination of tools and methods across the entire AWS global infrastructure, such as redundant and concurrently maintainable systems, as well as live system updates and migration. For example, in this case, example 1, EC2 used live system updates to perform the required security maintenance non-disruptively for over 90% of EC2 instances, with each maintenance completing in less than 2 seconds. AWS continuously invests in technology and processes to complete routine maintenance ever more safely and quickly, often with no disruption to customer instances. Q. How do I select the right instance type? Amazon EC2 instances are grouped into 5 families: general purpose, compute optimized, memory optimized, storage optimized, and accelerated computing instances. General purpose instances have memory to CPU ratios suitable for most general purpose applications and come with fixed performance, M5, M4, or burstable performance, T2. Compute optimized instances, C5, C4, have proportionally more CPU resources than memory, RAM, and are well suited for scale-out compute-intensive applications and high-performance computing, HPC, workloads. Memory-optimized instances, X1E, X1, R4, offer larger memory sizes for memory-intensive applications, including database and memory caching applications. Accelerating computing instances, P3, P2, G3, F1, take advantage of the parallel processing capabilities of NVIDIA Tesla GPUs for high-performance computing and machine/deep learning. GPU graphics instances, G3, offer high-performance 3D graphics capabilities for applications using OpenGL and DirectX. F1 instances deliver Xilinx FPGA-based reconfigurable computing. Storage-optimized instances, H1, I3, EIN, D2, D3, DIN, that provide very high, low-latency, I/O capacity using SSD-based local instance storage for I.O. intensive applications. With D3, DIN, D2, or H1, the dense storage and HDD storage instances provide local high storage density and sequential I/O performance for data warehousing, Hadoop, and other data-intensive applications. When choosing instance types, you should consider the characteristics of your application with regards to resource utilization, i.e. CPU, memory storage, and select the optimal instance family and instance size. Q. What is an EC2 compute unit and why did you introduce it? Transitioning to a utility computing model fundamentally changes how developers have been trained to think about CPU resources. Instead of purchasing or leasing a particular processor to use for several months or years, you are renting capacity by the hour. Because Amazon EC2 is built on commodity hardware, over time there may be several different types of physical hardware underlying EC2 instances. Our goal is to provide a consistent amount of CPU capacity no matter what the actual underlying hardware. Amazon EC2 uses a variety of measures to provide each instance with a consistent and predictable amount of CPU capacity. In order to make it easy for developers to compare CPU capacity between different instance types, we have defined an Amazon EC2 compute unit. The amount of CPU that is allocated to a particular instance is expressed in terms of these EC2 compute units. We use several benchmarks and tests to manage the consistency and predictability of the performance from an EC2 compute unit. The EC2 compute unit, ECU, provides the relative measure of the integer processing power of an Amazon EC2 instance. Over time, we may add or substitute measures that go into the definition of an EC2 compute unit, if we find metrics that will give you a clearer picture of compute capacity. Q. How does EC2 ensure consistent performance of instance types over time? AWS conducts yearly performance benchmarking of Linux and Windows compute performance on EC2 instance types.
Benchmarking results, a test suite that customers can use to conduct independent testing, and guidance on expected performance variance is available under NDA for M, C, R, D and Z1D instances. Please contact your sales representative to request them.
Q. What is the regional availability of Amazon EC2 instance types? For a list of all instances and regional availability, visit Amazon EC2 pricing. Micro instances. Q. How much compute power do micro instances provide? Micro instances provide a small amount of consistent CPU resources and allow you to burst CPU capacity up to 2 ECUs when additional cycles are available. They are well suited for lower throughput applications and websites that consume significant compute cycles periodically but very little CPU at other times for background processes, daemons, etc. Learn more about use of this instance type. Q. How does a micro instance compare in compute power to a standard small instance? At steady state, micro instances receive a fraction of the compute resources that small instances do. Therefore, if your application has compute-intensive or steady-state needs, we recommend using a small instance, or larger, depending on your needs. However, micro instances can periodically burst up to 2 ECUs for short periods of time. This is double the number of ECUs available from a standard small instance. Therefore, if you have a relatively low throughput application or website with an occasional need to consume significant compute cycles, we recommend using microinstances. Q. How can I tell if an application needs more CPU resources than a microinstance is providing? The CloudWatch metric for CPU utilization will report 100% utilization if the instance bursts so much that it exceeds its available CPU resources during the CloudWatch monitored minute. CloudWatch reporting 100% CPU utilization is your signal that you should consider scaling manually or via auto-scaling up to a larger instance type or scale out to multiple microinstances. Q. Are all features of Amazon EC2 available for microinstances? Currently, Amazon DevPay is not available for microinstances. Nitro Hypervisor Q. What is the Nitro Hypervisor? The launch of C5 instances introduced a new hypervisor for Amazon EC2, the Nitro Hypervisor. As a component of the Nitro system, the Nitro Hypervisor primarily provides CPU and memory isolation for EC2 instances. VPC networking and EBS storage resources are implemented by dedicated hardware components, Nitro cards that are part of all current generation EC2 instance families. The Nitro Hypervisor is built on core Linux kernel-based virtual machine (KVM) technology, but does not include general-purpose operating system components. Q. How does the Nitro Hypervisor benefit customers? The Nitro Hypervisor provides consistent performance and increased compute and memory resources for EC2 virtualized instances by removing host system software components. It allows AWS to offer larger instance sizes, like C5.18's large, that provide practically all of the resources from the server to customers. Previously, C3 and C4 instances each eliminated software components by moving VPC and EBS functionality to hardware designed and built by AWS. This hardware enables the Nitro Hypervisor to be very small and uninvolved in data processing tasks for networking and storage. Q. Will all EC2 instances use the Nitro Hypervisor? Eventually all new instance types will use the Nitro Hypervisor, but in the near term, some new instance types will use Xen depending on the requirements of the platform. Q. Will AWS continue to invest in its Xen-based hypervisor? Yes. As AWS expands its global cloud infrastructure, EC2's use of its Xen-based hypervisor will also continue to grow. Xen will remain a core component of EC2 instances for the foreseeable future. AWS is a founding member of the Xen project since its establishment as a Linux Foundation collaborative project, and remains an active participant on its advisory board. As AWS expands its global cloud infrastructure, EC2's Xen-based hypervisor also continues to grow. Therefore, EC2's investment in Xen continues to grow, not shrink. Q. How many EBS volumes and elastic network interfaces, ENIs, can be attached to instances running on the Nitro Hypervisor? Instances running on the Nitro Hypervisor support a maximum of 27 additional PCI devices for EBS volumes and VPC ENIs. Each EBS volume or VPC ENI uses a PCI device. For example, if you attach 3 additional network interfaces to an instance that uses the Nitro Hypervisor, you can attach up to 24 EBS volumes to that instance. Q. Will the Nitro Hypervisor change the APIs used to interact with EC2 instances? No, all the public-facing APIs for interacting with EC2 instances that run using the Nitro Hypervisor will remain the same. For example, the hypervisor field of the describe instance's response, which will continue to report Xen for all EC2 instances, even those running under the Nitro Hypervisor. This field may be removed in a future revision of the EC2 API. Q. Which AMIs are supported on instances that use the Nitro Hypervisor? EBS-backed HVM AMIs with support for INA networking and booting from storage can be used with instances that run under the Nitro Hypervisor. The latest Amazon Linux AMI and Windows AMIs provided by Amazon are supported, as are the latest AMI of Ubuntu, Debian, Red Hat Enterprise Linux, SUSE Enterprise Linux, CentOS, and FreeBSD. Q. Will I notice any difference between instances using Xen Hypervisor and those using the Nitro Hypervisor? Yes. For example, instances running under the Nitro Hypervisor boot from EBS volumes using an interface. Instances running under Xen boot from an emulated IDE hard drive, and switch to the Xen para-virtualized block device drivers. Operating systems can identify when they are running under a hypervisor. Some software assumes that EC2 instances will run under the Xen hypervisor and rely on this detection. Operating systems will detect they are running under KVM when an instance uses the Nitro Hypervisor, so the process to identify EC2 instances should be used to identify EC2 instances that run under both hypervisors. All the features of EC2 such as instance metadata service work the same way on instances running under both Xen and the Nitro hypervisor. The majority of applications will function the same way under both Xen and the Nitro hypervisor as long as the operating system has the needed support for ENA networking and storage. Q. How are instance reboot and termination EC2 API requests implemented by the Nitro hypervisor? The Nitro hypervisor signals the operating system running in the instance that it should shut down cleanly by industry standard ACPI methods. For Linux instances, this requires that ASPID be installed and functioning correctly. If ASPID is not functioning in the instance, termination events will be delayed by multiple minutes and will then execute as a hard reset or power off. Q. How do EBS volumes behave when accessed by NV interfaces? There are some important differences in how operating system drivers behave compared to Xen Paravirtual (PV) block drivers. First, the device names used by Linux-based operating systems will be different than the parameters for EBS volume attachment requests and block device mapping entries such as /dev/zeta and /dev/xvdf. Devices are enumerated by the operating system as /dev/0n1, /dev/1n1, and so on. The device names are not persistent mappings to volumes, therefore other methods like file system UIDs or labels should be used when configuring the automatic mounting of file systems or other startup activities. When EBS volumes are accessed via the NV interface, the EBS volume ID is available via the controller serial number and the device name specified in EC2 API requests is provided by a vendor extension to the identify controller command. This enables backward-compatible symbolic links to be created by a utility script. For more information, see the EC2 documentation on device naming and based EBS volumes. Second, by default, the NV drivers included in most operating systems implement an I/O timeout. If an I/O does not complete in an implementation-specific amount of time, usually tens of seconds, the driver will attempt to cancel the I/O, retry it, or return an error to the component that issued the I/O. The Xen PV block device interface does not time out I/O, which can result in processes that cannot be terminated if it is waiting for I/O. The Linux NV driver behavior can be modified by specifying a higher value for the NV.io timeout kernel module parameter. Third, the NV interface can transfer much larger amounts of data per I/O, and in some cases may be able to support more outstanding I/O requests, compared to the Xen PV block interface. This can cause higher I/O latency if very large I/OS or a large number of I/O requests are issued to volumes designed to support throughput workloads like EBS throughput optimized HDD, ST1, and cold HDD, SC1 volumes. This I/O latency is normal for throughput optimized volumes in these scenarios, but may cause I/O timeouts in drivers. The I/O timeout can be adjusted in the Linux driver by specifying a larger value for the nv_core.io_timeout kernel module parameter. Optimize CPUs. Q. What is optimize CPUs? Optimize CPUs gives you greater control of your EC2 instances on two fronts. First, you can specify a custom number of PUS when launching new instances to save on CPU-based licensing costs. Second, you can disable Intel hyper-threading technology, Intel High technology, for workloads that perform well with single-threaded CPUs, such as certain high-performance computing, HPC applications. Q. Why should I use Optimize CPUs feature? You should use Optimize CPUs if you are running EC2 workloads that are not compute-bound and are incurring CPU-based licensing costs. By launching instances with custom number of PUS, you may be able to optimize your licensing spend. You are running workloads that will benefit from disabling hyper-threading on EC2 instances. Q. How will the CPU optimized instances be priced? CPU optimized instances will be priced the same as equivalent full-sized instance. Q. How will my application performance change when using optimized CPUs on EC2? Your application performance change with optimized CPUs will be largely dependent on the workloads you're running on EC2. We encourage you to benchmark your application performance with optimized CPUs to arrive at the right number of PUS and optimal hyper-threading behavior for your application. Q. Can I use optimized CPUs on EC2 bare metal instance types, such as i3.metal? No. You can use optimized CPUs with only virtualized EC2 instances. Q. How can I get started with using optimized CPUs for EC2 instances? For more information on how to get started with optimized CPUs and supported instance types, please visit the Optimized CPUs documentation page here. Workloads Amazon EC2 running IBM. Q. How am I billed for my use of Amazon EC2 running IBM? You pay only for what you use and there is no minimum fee. Pricing is per instance hour consumed for each instance type. Partial instance hours consumed are billed as full hours. Data transfer for Amazon EC2 running IBM is billed and tiered separately from Amazon EC2. There is no data transfer charge between two Amazon Web Services within the same region, i.e. between Amazon EC2 US West and another AWS service in the US West. Data transferred between AWS services in different regions will be charged as internet data transfer on both sides of the transfer. For Amazon EC2 running IBM pricing information, please visit the pricing section on the Amazon EC2 running IBM detail page. Q. Can I use Amazon DevPay with Amazon EC2 running IBM? No, you cannot use DevPay to bundle products on top of Amazon EC2 running IBM at this time. Amazon EC2 running Microsoft Windows and other third-party software. Q. Can I use my existing Windows Server license with EC2? Yes, you can. After you've imported your own Windows Server machine images using the Import Image tool, you can launch instances from these machine images on EC2 dedicated hosts and effectively manage instances and report usage. Microsoft typically requires that you track usage of your licenses against physical resources such as sockets and cores, and dedicated hosts helps you to do this. Visit the dedicated host detail page for more information on how to use your own Windows Server licenses on Amazon EC2 dedicated hosts. Q. What software licenses can I bring to the Windows environment? Specific software license terms vary from vendor to vendor. Therefore, we recommend that you check the licensing terms of your software vendor to determine if your existing licenses are authorized for use Amazon EC2.